Hello everyone and welcome to the intense crash course in Objective-C. This is week number 3 with your instructor, myself, Jason Busby, and also joining us, Mr. Nelson LeKay.
Yay!
Hi.
Also, we've got the lovely Nina Covington.
Hi guys!
Sitting in more as a student. I've got all of my monitors up and I am carefully monitoring for questions all over the place. Emails, questions panel in the GoToWebinar meeting, and BuzzNet. Okay, just kidding about the email, so don't get carried away.
Yeah.
Tonight's going to be an interesting night. We've got a lot of stuff to cover. We're going to be breaking tonight into 3 parts. So do me a favor, and if we're 6 hours in, no laughing at me if we're still in part 1. Nah, that's not going to happen tonight. I've put a lot of thought into how I want to go through this tonight to try to keep things as streamlined as possible. Part 1, I'm going to give you a quick look at what's coming for tonight. And then we will pass things over to Nelson to do a review and go over the homework for you guys. But part 1 is going to be all about pointers. It's going to be an introduction to pointers. We're going to take a look at the Indirection operator. We're going to look at the reference, or what's often known as the address of operator. We're going to talk about declaring pointers, initializing pointers, invalid initializations. We're going to do, of course, a bunch of pointer examples. We're going to talk about passing arguments by value, and then passing arguments by reference using indirection. And we'll take a quick look at void pointers as well. Now, there's a lot of other cool stuff that I would love to do with pointers. But I've already said this a couple of times. We'll need to look at doing a workshop all about pointers so that we can get into all of the other cool stuff. This is all that's needed for what we are covering tonight, and to give you guys a basic understanding of what you're going to be looking at when we move over to Objective-C in the later part of the evening. It's going to be really important. No pointers. Again, it's only for what we need at the moment. But a workshop where we could get into using function pointers and all of that fun stuff would be really cool. But again, this is all that's needed here. And we don't even need to do void pointers, but they're interesting. Okay, so part 2, we're going to be looking at just a quick introduction to object-oriented programming. In fact, I've divided this up into part 1, and then part 2 is going to come next week. So tonight we're going to be talking about classes and instances. We'll be talking about the things you'll find inside of classes, like instance variables, methods. And then we'll be talking about a couple of key concepts for object-oriented programming, such as encapsulation and inheritance. From there, we're going to be moving into part 3, where we will take a look at Objective-C. We're going to start out simple with a very simple Hello World application. We'll take a quick look at the anatomy of that simple application. We're going to talk about the foundation framework and what kinds of things that you can expect in it. From there, we'll be taking a look at creating an object-oriented message dispatcher. Suddenly my language just completely changes. We step it up. A message dispatcher? What? Okay, we're going to be making an object-oriented Hello World application. Is that better? Then we're going to take a look at the anatomy of that application, which is going to get us into a lot of stuff. We're going to be looking at defining classes, instantiating classes, creating methods. We're going to talk about messaging, the messaging anatomy. We'll also talk about basic memory management as well. So we've got a couple of things to cover tonight. It's not that bad, just a couple. But
sounds like fun.
Yeah, it sounds like a fun evening. So there you guys go. That's what we've got in store. With that, I want to go ahead and hand this over to Nelson. Look at that. I've talked for less than 4 minutes.
And Chris, I do have your homework.
Look at Exxon's post in BuzzNet. I think it's funny.
It's like before we started recording, they bet each other which one could talk faster. Was I really talking faster? Oh, no.
I take that as a challenge, and you know how fast I can get.
No, we know that you're extremely fast. Okay, so with that, Nelson, quick review before you get into Fibonacci. What did we talk about last week? I don't remember anything.
Oh, yeah, we talked about functions. And we talked about defining functions, prototyping functions, and invoking functions. So, yeah, that's pretty interesting stuff. So, for example, what we have right here with main is we have an example of a function. And we know it's a function because of the syntax we see right here. We have a type, which is known as return type, followed by its name, which is just any valid identifier, followed by its parameter list, which in this case is empty, followed by a block. And of course, as we know, a block is defined as an opening and closing curly brace that contains statements. So we talked about creating other functions. So for example, let's say I had some awesome stuff in here, like for example, int left equals 0, right equals 0. So let's say I define two integers and maybe another sum equals 0. So 3 integers. Then I might want to say something like printf enter number. And then I could say scanf, pass in the D format specifier to specify that we want to pull in an integer. So this is, I know this is review from 2 weeks ago, but I wanted to start off with this and see how we can break it into functions. So let's go ahead and get our left, and then let's say enter number. And then let's do our scanf and bring in another D and bring in our, I'm not used to this keyboard. Bring in our right.
Now you know how I feel when I'm typing on my little bitty one during these classes.
Yeah, I need to plug my DOS keyboard into this. So then we can go ahead and say printf the sum is blah. So now if I go ahead and run this program, we'll get enter a number. Let's start with 5, enter another number 5, and we get the sum is 10. So that's all nice and good and everything, but if you wrote your entire program like this, you're going to be very, very, very sorry. And the reason is because we don't have any separation of concerns, and at the moment our main function is entirely responsible for the entire program's execution. What if, for example, I wanted to change the way that I received integers from the input window? I would have to change that functionality in 2 different places, enter a number and enter a number. On both these instances, I would have to change the way this code worked. And you also notice that the code itself is starting to lose readability because we're not delineating our steps very well. Now, in this particular case, yes, you can see the program in 10 seconds. You should be able to understand it's a program, but when it gets larger, you're going to have problems. So what we talked about was introducing functions, which functions give us a nice reusable, consistent location to place code that, like I said, can be reused throughout the entirety of the application. Now, the thing about functions is they first have to be declared at some point. Now, you can declare them in their definition, but you can also declare them using prototypes. So I'm going to go ahead and prototype out a function called getInteger. Then I'm going to also prototype a function called add. So now I have 2 prototypes, but if I were to go ahead and rewrite this code using those prototypes, my code would fail. So let's go ahead and see what using main with these functions would look like. Now I can say int left equals getInteger, right equals getInteger, sum equals 0, and now I can go ahead and say sum equals add left and right. And now I have the code like this. But if I were to run this, notice how it says build failed. And that's because we promised the compiler we have 2 of these functions here, getInteger and add, but we actually lied. We didn't actually define these functions anywhere. So we do have to somewhere, now it doesn't have to be above main, which is the good thing, but somewhere within our program, we have to actually fulfill the promise that we gave to the compiler here in lines 3 and 4. And so to do that, I can go ahead and create the definition of these 2 functions. Now the definition always contains the signature. Wow. Sure. There we go. Always contains the signature, which you'll notice looks like it's the same thing as on line 3, and you'd be correct. However, instead of terminating it right there with the semi, I'm going to give it a body. And the body is going to be in the form of a block of code, again, delineated by curly braces, and I can put statements within this body. So now I can go ahead and define the behavior I want to happen whenever getInteger is invoked. So I'm going to say printf enter a number. I'm going to go ahead and create a variable up here called result, initialize it to 0. And then I'm going to go ahead and say scanf and get result into that value. I'm going to go ahead and return result. So now we've defined our get integer. Notice how my code is actually considerably smaller. And actually, this is poor form right here. I'm going to fix this up a little bit. I don't want to do that. That's ugly. I don't know why I did that. Jason, why'd you let me do that?
I'm just, sitting here in shock.
Okay, so there our code looks a little bit nicer. But now you see our code is, our main method function, is already considerably more readable than it was before. And our repetitious lines of code have now been abstracted. There's a fun word that you'll hear me use a lot, but they've been extracted into this concept of get integer. Main doesn't care how get integer works, just as long as it returns an integer. That's all it cares about. The implementation of get integer is responsible for saying what happens when this function is actually invoked. So now I'm going to go ahead and finish the program by defining the add function we've already declared here on line 4. So I'm going to say int add, int left, int right, return left plus right. So now we've created our entire program, and if I go ahead and run it, enter number 5, and 5 plus 5 is 10. So that's a quick overview of what functions look like, when you might want to use them, how they clean up your code, and some of the rules that you have to follow when doing functions.
Okay, very good. So then the next big thing that was covered after we went over functions, we of course talked about the stack, which the most important thing to take away with an understanding of the stack is the fact that our local variables are local to these functions.
Right, so let me go ahead and actually clarify that a little bit, because I can see how the names of some of my variables might be confusing to a person who might not quite understand local variables. So if I called, instead of left, I want to call la-di-da, instead of right, whoa, hey there, and some bleh. So now notice how, because I've changed the names of these local variables, I now get errors. And that's because these local variables that are down here in these other functions are not visible to main. So now I can go ahead and fix this program by refactoring my code to use the correct local variables. So, well, hey there, and bleh,
Bleh.
and bleh, and
Best refactor ever.
I think this is probably the first refactoring I've ever done that actually resulted in less clear code. But the point is, and if you use variable names like this, you will fail. But in this case, I just wanted to stress the fact that these local variables are local to main, and they don't have any meaning anywhere else. I can name them whatever I wanted to, and it's not going to interfere with other local variables that I've defined in other functions.
Cool. All right, and then after scope, the next thing that we talked about, the next big thing was recursion. And with recursion, we issued the Fibonacci sequence as homework.
Right, so if I wanted to go ahead, let's quickly just take a look at what recursion is real fast. So I'll just pull up another example real quickly. Let's do something like int count down, int index, and then I'm going to say, or I'm not going to return it in, I'm going to just do void. And then I'm going to say countdown from 20. And what's countdown going to do? Well, countdown is going to do countdown int index. Now, with recursive functions, the first thing that you have to always have is some sort of condition that will terminate the recursion. So what I'm going to do here is I'm going to say if index is smaller or equal to 0, return. So that's my condition that will terminate the recursion. Otherwise, what I'm going to do is I'm going to say printf index equals d, new line, index, and then I'm going to invoke countdown index -1. And so now if I run this program, notice how it'll count down all the way from 20 down to 1. And it does that because it continuously invokes itself until it hits this termination.
Okay.
So does this so far bring back nightmares that people had from trying to understand?
Nightmares? What the heck are you talking about? There's no nightmares to this. Everybody loves this stuff. Now, of course, Jonathan wants to know, is there any reason to use countdown index -1 and countdown minus index?
Yes, and the reason is because this will actually fail. Can anybody tell me why this will result in a Stack Overflow exception? Okay, well, he says minus index. This is pointless, and here's why it's pointless. This index variable that I'm passing in is not the same index variable as up here. In fact, you don't mind this review taking...
No, it's no, just do it. Do it!
Okay, let me go ahead and I'm gonna see. I know how to use Photoshop too.
No, you don't. Actually, yeah, you do. You're learning it quite well now.
I'm gonna bring you over, and I'm gonna go full screen, and then I'm going to take you, unplug you from that, and then unplug you from that, and then plug you into the cord doesn't reach. Let me grab my wireless dongle.
No grabbing dongles on the air? What's wrong with you?
Goodness, this is a PG programming.
Yeah, man. PG programming. Okay. Ha! Okay, go, draw.
With any luck. Oh, hey, look, it actually worked. Let me... Where's my display?
I love how he was so surprised.
Well, yeah, it's a Mac. I was kind of surprised. Okay, so what we have here with that function, the function looked like, whoa, that is messed up. Something's wrong with my wireless dongle. Let me bring it closer. There we go. Okay, so with our void countdown, it looks something like, I'm just going to say int I, because I'm lazy. And then it said, if I is less than 10, return. And I know I'm leaving out punctuation here, but don't hate me. And then I'm going to say count down I. So this is basically what our function did. It didn't look exactly like this, but just bear with me. For example, this should be fine. Now, Exxon says, I now understand why Jace is the one that does the whiteboard. It's better than some of my earlier whiteboards.
Yeah, it's significantly better. Continue.
Oh, I don't have Scrubby Zoom? Madness. Okay, so here's our nice little countdown function. And notice how it has this int I. That int I goes on the stack. So here's our stack. Now our stack currently has main on it and everything that's inside of main. And now it also has countdown. What's inside of countdown? Int I. Right? Is everybody with me?
Yes.
Okay. All right, is everybody with me?
Yes.
Okay, so now we have countdown with an int I in it. When we invoke countdown again, so when countdown gets invoked again, what happens is another countdown gets pushed on to the stack with another int I. These two int I's are different. They're in different memory addresses. They're completely 100% isolated from each other. If this int I equals 10 and this int I equals 9, then that's fine because they're completely different memory addresses. They don't have any correlation between each other. If we were to add another countdown to the stack, that would be a different int I. So what I'm getting at is if I took this int I and I decremented it and I said I equals I minus 1, this is only going to affect this one stack frame. That int I is not going to be the same value that's represented in any of the other stack frames. So as far as why I chose to do I minus 1 instead of I minus I, if I did minus I, here's what happens. I gets decremented. So if I was, let's say I equals 10, now I equals 9, but then I gets copied into the next stack frame. This I that's right here is not going to affect the other stack frame. So there's no reason to do a decrement operator here because it's not going to affect anything else. It's isolated completely. Does that answer who asked that?
Jonathan did.
Is that kind of making sense? The I is completely isolated.
He's still not following.
So not following. So I gets copied to the recursive method with I minus minus. It does. It gets copied. And the original I doesn't matter. There's no reason to do the I minus minus. And yes, I plus 1 will copy it too. See, if I do I plus 1, that'll also copy it. Wow, my thingy isn't working. There we go. If we do an I plus 1, this will copy it. That will take, let's say I equals 10. This I plus 1 will evaluate into I equals 9, and then that 9 will get fed into countdown. The exact same thing would happen if I did countdown. I think what I'm not, what I could be not quite explaining right, is that if I did countdown minus I, this expression still gets evaluated into, okay, let's just, for sake of argument, I equals 10. This expression still gets evaluated into 9, and then the 9 gets copied. If I do count down I minus 1, this expression still evaluates into 9, and then that 9 gets copied into the next invocation of countdown. It does the exact same thing. The only difference here is that this minus minus, not only does this expression return 9, but it will also decrement I. So if I were to write out the I minus minus example in its entirety, it would look like this. It would say I equals I minus 1, countdown I. But this, why are we doing that here? There's no reason to do that. It's not going to do anything. It's just wasted instructions. So that's why the I minus 1 is better, because we don't waste the instruction of assigning I. Because remember, this I is completely different than the other I. By decrementing the I in a different stack frame won't decrement the I in the other stack frames. But then would you ever use I minus minus if we wanted to decrement it? But we're not trying to decrement it. A decrement and an increment, those statements imply that we are going to be changing the value of a variable. We don't want to decrement or increment our variable. We just want to subtract 1 from it and copy it down. So is this making more sense to people? Right. I want in this case, I do want the original value to remain.
Read the question. What Sibai asked.
Who? So in recursion, you don't decrement. I mean,
it depends.
It depends. It depends if you want to decrement. My point in saying this is that in this particular example, doing a prefix decrement operator does not make the code invalid, but just adds an additional instruction that doesn't do anything.
Right. That's pointless.
Yeah. Yeah, I mean, you could certainly do, like, if I wanted to add a for loop that had an increment operator, yeah, if it serves a purpose for anything. But in this case, the decrement does not serve a purpose. So it's not a matter of never use decrements or increments in recursive functions. It's it's not needed if all you're wanting to do is invoke the recursive function with +1 or -1 added to the counter variable. But Zion West said it right there. You want the original, I'm going to say, the original variable to remain its original value. Yes.
Well, it's not that you want it to. It's just putting anything else to mess with. It's irrelevant. It's pointless because the way you've structured your function here is that you keep calling yourself, but each time you're calling yourself, you're just making sure the number that gets sent in is one less. You don't care about the number, how it remains in the function itself. And the reason is because of the structure of the function. Because once you finally get to a point where I is, well, what do you have there? Less than 10? No, 0. So once you're less than or equal to 0, so basically once you hit 0, we're going to return. And then when we come back to the other guys, jump back over to the code real quick. Because here's the big one. Once you return back from countdown, don't forget line 17, we return back to there. Where are you at? I don't care what else you do. You're at the end of the function. We're not like in a loop or anything. So once we're here, once we come back so let's say we're at the second to the last countdown call. And so in that one, we decrement down to, we do count down again. We call ourselves for the last time where we decrement it down to 0. Now in line 13 in this new countdown, we are equal to 0. So we return. Now when we unwind the stack and we come back to line 17, well, what's the next thing we do? Line 18. It's the end of the function. So we return back to the guy before that and the guy before that. And we just unwind the stack all the way back. So what Nelson's getting at is by doing anything else that's actually affecting that variable, like if you did another line afterwards, or it's irrelevant. It's not irrelevant in the fact that we're actually causing extra CPU cycles to be used, so it's not very efficient. Hopefully that helped a little bit. All right, and Saturn just said, the confusion lies in the difference between I-1 and I-, which at least for me, reading books seems interchangeable with no difference. And Nelson's tracing the entire thing out for you.
Yeah, somebody did ask.
Go ahead.
Sorry, I wasn't trying to interrupt you by doing
No,
that.
you're fine.
Somebody asked, how does the I in if I is smaller than 0 find out about the I way down in the recursion? Well, this is how. The first invocation of countdown has a 5 as its argument. Second iteration has a 4 as its argument. Third iteration has a 3 as its argument, and so on, and so on, and so on. Now, every one of these countdowns has a check in the beginning of it saying if I is less than or equal to, I think I did, 0, then don't continue. So this check is performed every single step of the way. In this case, is 5 less than or equal to 0? Am I saying that right? Does this check pass on 5? And the answer is no.
Are you getting yourself twisted with your own? Sorry, that was just funny.
Does this check pass here? No. Does this check pass here? No. Does this check pass here? No. Does it pass here? No. Does it pass here? Yes. So in this case, this one will not continue. So that's how the I gets passed down. The I gets passed down because the value of the argument that's passed into the countdown invocation gets smaller every time countdown is invoked.
Right. And then now show the unwinding, because once that happens, now we're just going to unwind all the way back up.
Right. So once it...
Because remember, execution is then handed, once the stack frame is unwound, we then hand back to where we called, and there's nothing else to execute. We're done. So we pop that off the stack. Then we go back to the next one prior, pop that off the stack, and we just keep going all the way back. Yeah, that's right, Mandrill. You guys are becoming experts. I love it.
Okay, so let's see here. The visualize the difference between I-1, I-minus. Saturn, did that get answered or? Well, yeah, they okay, good. How do you unwind? Kick your feet up? Yes.
Yes, generally. With beer.
Yes, and liquor.
Okay, so if this makes sense, this is important, very important, because now we're going to be taking a look at the homework.
Keep on forgetting that I don't have Scrubby Zoom enabled for some reason.
Just bring your toolbar back at the top and turn it on.
It doesn't wanna. I can't.
Oh, interesting. Okay.
It says nope.
Okay, so let's go ahead and talk about the homework now. Hold on, I'm going to plug my tablet in so I can actually get it charged. I think that's probably why it was messing up.
And I want to add this into the discussion while Nelson is plugging his tablet in. The very, very first thing as a programmer that you need to do when you start coding something is to make sure that you can mechanically work it out on paper. You need, and what I'm getting at is you need to have a very clear understanding of what it is you're trying to do. If you don't know what the Fibonacci sequence is, how are you going to sit down and code it? Now you're going to make things twice as complicated for yourself.
Right. I mean, basically, all programming is instructing the computer to do very, very, very specific steps to accomplish a very, very, very specific problem. If you don't know the problem that you're trying to accomplish, you're not going to be able to write software that accomplishes it.
Precisely. That's critical to understand that for those of you that are really new to programming.
Okay, so let's go ahead and write out Fibonacci real fast. This is kind of a classic computer science problem. Well, first of all, I guess I can go ahead and define what it is. Fibonacci sequence is going to be, it always starts off with 2 1s, and then the next number is always the last 2 numbers added together. So 1 1, 2, 3, 5, 8, 13, 21, 34, and so on and so on. So let's go ahead and write a function that'll compute any given item. So also I want to define what I mean by an index. This is the first index of the Fibonacci sequence for the purposes of the homework that I defined. This is the second index. This is the third, fourth, fifth, sixth, seventh, eighth, ninth. And I bet I totally just confused some people because they might have noticed I was counting 1 behind, and I was doing that on purpose because I'm basing this off zero-based indices. Because every programming language should be zero-based indices, and the programming languages that aren't, including Cold Fusion and Visual Basic, should really be modified so that they are. So if I go ahead and add an int, or if I go ahead and prototype out the function that I want to define, I'm going to go ahead and say int fib, int index. So it returns an integer, it's called fib, and it takes in an index. I would type out Fibonacci if I knew how to spell it. So let's go ahead and define this function. So we've declared it there on line 3. Now let's go ahead and define it. And what's it going to do? Well, the first most important thing is it's going to have its termination. We're going to need to terminate the recursion at some point. So what am I going to do? I'm going to look at this little chart, handy chart right here, and we can see a very clear case of when the sequence should be terminated. And that is going to be when the index is equal to or less than 1, we just want to return 1. So that'll take care of the first 2 indices of the Fibonacci sequence. So that'll be awesome. If index is smaller or equal to 1, return 1. So now we've taken care of the first 2 cases of the sequence. Now for the rest of the sequences, this is going to break everybody's head.
So make sure you have insurance before watching this next part.
Yeah. I'll explain that in a second. I'm going to go ahead and say for, not far, no implicit typing. I equals 0, I smaller than 10, I plus plus, printf, fib at I equals D, new line, and then fib of I, and then return, or run. So now I see 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. So that's what I wanted to do. So the funny thing about this particular problem is the most classic implementation, and I'm sure there's a variety of implementations you can use, really. I mean, there are a variety of implementations you could use. In fact, there are constant time implementations you could use if you wanted to, if you're particularly adept at math. But in this particular case, this is pretty much the simplest, most straightforward implementation that uses recursion. So what's going on here is every invocation of fib results in basically two branches of the function getting invoked. So let's break this down. Let's say we want to go ahead and do fib at 3. So what's fib at 3 going to do? Well, fib at 3 is going to say return fib at 2 plus fib at 1. Hold on, I'm thinking. Yeah, sorry, I was getting I was thinking too much about Visual Basic, so I was getting my
Stop reading BuzzNet.
indices. Yeah, well, I can't help it. Okay, so right now what we have is fib 2 of fib plus fib 1. What's fib 2? Fib 2 is return fib at 1 plus fib at 0. So actually, I'm gonna write this a little bit different. I'm gonna say fib 2 equals fib 1 plus fib 0, and fib 3 equals fib 2 plus fib 1. And something's wrong with my formatting here. I'm gonna make this. I'm gonna
Inconsistent formatting.
There we go. I've consistified it. Okay, so now what's fib 1? Fib 1 is, can anybody tell me what fib 1 is? What does fib 1 evaluate into? No. Scion West. Read closer. Yep. Ray Lewis got it right, and Saturn got it right. It evaluates into 1. What's fib 0 evaluate into? Anybody?
Come on, guys. Come on. Do it. Do it. Jonathan, redeem yourself. Yep.
Nope, it turns into 1. How do I know that fib 1 and fib 0 both turn into 1? Well, I know that because of the second branch here, or this first branch here. Notice this if statement. This is the termination. If the index is equal to or smaller than 1, return 1. So now what I can do is I can simplify my entire, so I can follow this through by simplifying it. So let's go ahead and simplify fib 3. Fib 3 equals, so if I were to simplify fib 2, what would I put right here in parentheses?
Oh, I know you're dying to put an answer up in BuzzNet.
Talking to me?
No. Talking to our students.
What do I'm simplifying fib 3. What am I going to replace this fib of 2 with inside of these parentheses right here for fib 3? Yes, Ray Lewis redeemed himself. I'm going to replace it with fib of 1 plus fib 0. Now I'm going to say plus, and what am I going to place in here now? So keep in mind that I'm simplifying this expression right here. What does this expression simplify into? I have the answers all in the comments right here. Yep, it simplifies into 1. So now, let's go ahead and simplify this expression further. Fib 3 equals, what's the simplification of fib 1 again?
Look at line 29.
1. What's the simplification of fib 0?
Look at line 30.
1.
1. What's the simplification of 1?
1.
Exion got it! It's 0! What?
So now what do I have? I have 1 plus 1 equals 2 plus 1. And what's 2 plus 1? It's 3. So fib3 equals 3. And I see that that is indeed the correct answer. So notice how I was able to simplify the expressions down by looking at the recursion, the nature of the recursion, I was able to simplify the expressions down. So this is, let's go ahead and do another one. Let's do 5 real fast. So I'm going to go ahead, I'm going to nucle this. Let's do fib5. So what's fib5? Fib5 equals, come on everyone, what's fib5? What does that equal? Now, I'm not looking for the actual answer of fib5. I'm looking at what does the expression turn into? Fib4 plus fib3, right. So it turns into fib4 plus fib3. Okay, let's simplify the first one. What does fib4 turn into? Anyone?
Look at line number 21.
Yep, fib4 turns into fib3 plus fib2. And then I also have this fib3 at the end. I'm going to line up my formatting a little bit so this will make a little bit more sense. Okay, let's simplify the other expression. Actually, I'm not going to do that on a different thing. What's fib3 turn into? Anyone? Fib3 is going to turn into fib at 2 plus fib at 1. So now we have our expressions simplified a little bit. So now let's simplify further. Fib5 equals fib3. What does fib3 turn into? It turns into fib2 plus fib1. So now what does our fib2 turn into? Well, fib2 turns into fib1 plus fib0. Okay, let's format this a little bit nicer here. Sorry, I'm trying to keep this as formatted nicely as possible. So fib2, the formatting is even confusing me now. Okay, so then we're going to do plus. What's fib2 simplify into? Fib2 simplifies into fib1 plus
fib0.
Right.
Okay.
Nina's like, holy crap, I actually got one. That's it. I'm now an expert programmer. I retire.
Yeah.
Okay, so then what's fib1 turn into?
Oh. Wait. Fib1 plus fib0?
Answer was on the board a minute ago.
1.
Yep.
1.
Okay, so let's simplify this further. This is how the recursion works, basically. You just continuously simplify until you reach your termination. What's our termination here? Our termination is this 1.
Right.
See how the recursion just stops because we've hit our condition. So fib5, let's simplify fib2. Fib2 simplified is blah, blah, blah. Fib1 plus fib0.
That's not a 0 that you wrote.
That's a
That's
2.
a 2. 2.
I was just seeing if everybody's paying attention. Okay, so fib, that blah, blah, blah. What's fib1 turn into? It turns into 1.
1.
Plus, what's fib1 turn into? 1. What's fib0 turn into?
0.
Plus, what's fib1 turn into?
1.
What's fib0 turn into? 1. Whoops.
0. Yes?
No, it turns into 1.
Oh, what? 1. Oh.
Fib0 turns into 1. See if index is smaller or equal to 1 turn into.
Oh, that's right, because it returns 1. Sorry.
And then let's go ahead and plus 1. And I don't know if these parentheses are even close to right now, but whatever. So finally, what do we have? Fib5 equals 1 plus 1
Plus
plus
1.
1 plus 1 plus 1 plus 1 plus 1 plus 1.
Oh my.
Which, if we go ahead and count the ones, we have 1, 2, 3, 4, 5, 6, 7, 8. And what's fib 5?
8.
Okay, so how's everybody feeling?
I don't think they get it. I think you need to do fib 639.
I agree.
Breaks at 47. Oh, right, that's because of the overflow. Integer overflow. We won't talk about that. But there's an actual reason why Fibonacci will become. People are saying it's becoming negative around 50. See, the funny thing about recursive functions like this is they take exponentially longer to execute. So notice how it's taking a long time to chug through this.
That's because you got an old computer.
I actually do have an old computer. This
Yeah, I
is
know
a 2011 MacBook.
Oh, that's so out of date. You haven't.
I
Yeah, I was about to say you haven't thrown that away yet. Jeez.
Woo.
Yeah, I'll give my MacBook to anybody who wants to buy me one of the Retina ones.
Nice.
Okay, but anyway, this will eventually start turning into negative numbers. And the reason it starts turning into negative numbers is because of integer overflow. But this isn't a lesson about integer overflow. So how's everybody feeling about Fibonacci? And how do I stop this?
You can hit the stop button at the
hit
top.
the stop button up there.
There we go.
Yay.
Okay. Is everybody feeling good?
Does this make sense? Remember, we're here for you guys. If you have questions, ask. Also, for those of you that have not yet turned in the homework, it has been spelled out in front of you. All you need to do is take a few minutes, quickly copy it, and turn the darn homework in.
Actually, I want to do one more thing.
Fibonacci 649? All right.
Fine.
That's right, Rowdy. Alt print screen. Happy camper. Review.
I don't have Scrubby Zoom. You know, I'm going to complain about this every single time I...
Ooh.
Okay, so last thing I want to do, just to completely drill the point home. I didn't mean to do that. What's the keyboard shortcut to step back, Jason?
What, Command Alt Z?
Command Alt C. Okay, there we go. Sorry, I don't use Photoshop on a Mac. Okay, so fib FB. Fib 4 equals fib 3 plus fib 2. Fib 3 equals fib 2
plus fib 1.
plus fib 1. Fib 2 equals fib 1 plus
fib 0.
Fib 0. Fib 1 equals 1.
1.
1 plus fib 0 equals 1. Fib 1 equals 1. Fib 2 equals fib 1 plus fib 0. Fib 1 equals 1. Fib 0 equals 1. Bring down the addition. So now what do we have?
1 plus
we
1
have
plus 1 plus 1.
1 1 plus 1 plus 1, 1 plus 1 plus 1 plus 1 plus 1. We have this.
We.
We have a work of art. Hooray!
It's beautiful.
So here, let me point out the ones. 1 plus 1 plus 1 plus 1 plus 1. So we have 1, 2, 3, 4. I think that's the right answer. Fib 4 equals 5.
That's you missed one, the one on the far right. You pointed to it there, but when you went back and counted them, you didn't include it.
Oh, 1, 2, 3, 4, 5. Yep, 5 ones.
Good.
Yay.
All right. So any questions? No? Good. Fantastic. No
All
questions
right.
at all. Looks like everybody's got it. If you have not turned in your homework, please, you have no excuse now. Get your homework done. Get it turned in, please. Okay? We dropped 50% of our submissions from last week. Unacceptable. Unflipping acceptable. Slackers. That's right, Rowdy. Don't make me sick Rowdy on you guys. There's a reason he's got that name. All right. What we're going to do. Yeah, Nelson, were you about to say something?
I was about to point out the time a little bit.
I know. I'm going to let everyone know. All right, guys. We're going to go ahead and take a break. When we get back from break, we're going to start on the world of pointers. If we start now, Nelson will die because we've been going about an hour now, and I'm sure he needs his break. So take a quick break, 10 minutes. Let's get back and get going. So I'm pausing video now. Hello, everyone, and welcome back from the break. So what we're going to do for tonight is we're going to start out with a look at pointers. So first thing I need to do is get reacquainted with Photoshop.
Hello, Photoshop.
Pointers. So we need to look at what they are, why would we want to use them. There's a lot of different things that we need to talk about. So basically, pointers are very powerful structures that can be used to work with variables, functions, and data structures through their memory addresses. Now, for whatever reason, beginners just get overwhelmed with the concept of pointers. And in this class, that is not acceptable. Rowdy Bull will be issued a taser, and anyone who starts getting stressed out by what pointers are shall be tased by Mr. Bull.
Oh, my.
That's right. So everybody keep up, okay? We all know that if we want, we can come in here and declare a variable. We start out by declaring a variable by specifying what? What's the first thing we need to specify when declaring a variable? Anyone? The type. Thank you, Mr. Lewis. That's right. So we first need the type. Let's do an int. See, look at that. I went old school. I backed all the way back up to like week number 1, and half you guys just fell out of your chairs. What's up with that? So I'm going to say int x. So what does this actually do? Yep, C-by just got tased.
I was tased.
We know that this is going to have a memory address assigned to it. And if I turn around and say x equals 32, so if I initialize x, 32 will now reside in this memory location. Right? Right.
Yes.
Good. Now, I'm going to actually give this a number. This is the address. I'm going to say 0x. This is a simplified address, by the way. 5f. So this is a hex number. And for those of you that are looking at it with crossed eyes right now, it's just a number. Okay? It's just not base 10. It's just a number. That's the only thing you need to care about. That is what is at that location. We saw that if I wanted to take advantage of scanf, I'm not going to write everything out here. Well, first of all, I'm not even going to spell things right. What's up with that? If I come in here, we saw that if I wanted to populate X with whatever the user typed in from their keyboard, I needed to come in here and use the ampersand. And then the variable that I wanted that data to be stored in. Now this is where we have actually been using pointers in a sense, because that's what scanf takes in. You guys have already seen that when we go in and we start working with functions, these guys they're like iron boxes designed to do a specific task. Main, scanf, which exists and is defined elsewhere. But we know that variables inside of main cannot see things inside of scanf, and things inside of scanf cannot see variables inside of main. And this is called what? Local scope.
Yes.
Local scope. Okay, good. So the scope of our variables is limited to just, think of binoculars. Man, Logan and I got in such a big fight over this in the past. But this is just a simple analogy. You pick up a pair of binoculars, you look through them, and you're only looking at a specific thing. Everything else that's outside of the binoculars, let's pretend these binoculars are mounted on a stand and cannot be swiveled. So you look through them. I'm now looking at the puppy that is walking around on the road. And that puppy is within scope. I can see him. So if I couldn't see things on the left or the right, I couldn't see the car coming. That's out of scope. So scope comes down to what we can see. Now we saw that we have this stack. And we saw on the stack that our stack frames are added on from higher address down, starting out with main. And this is where we're holding our local variables for main. We then add on another stack frame when we call scanf. Now there's a variable back over here. He's right there. I drew him as a big circle for X. Now remember, X is an identifier for us so that we can identify in plain English a name that makes sense for the variable. So we don't have to remember 0x5f. But when we go to scanf, he's contained in his own stack frame and he can't see it. But if scanf takes in a pointer to that address, so let's say inside a scanf, he's got a variable in there, but it's a special kind of variable. It's a pointer variable. And pointer variables point to memory locations of variables. They may point to other things as well, but we'll discuss some of that later. So now this guy, this pointer, is actually pointing to that location. Okay. That means that now inside a scanf, when somebody types in a number, remember scanf is executing, we're down here in execution. We no longer know nothing about that. Gone. But if somebody types something in and hit enters, since we passed in the, here goes the first big one.
Address.
The address of X. Since we passed the address of X in, scanf now knows that we're really looking back here at mains X. So now, inside of scanf, if we were to indirectly, let's get into some fancy words. If we were to indirectly assign a value to that pointer, we would actually be putting the information back over here in it. And do you have to... All right, before we start hopping into questions, let me finish through explanations and stuff first. And I think some of this will become a little bit clearer, Jonathan. And then we'll come back around. So right now, I'm just trying to show you guys the first basic example, something that you've already been using since week number 1 of this crash course. And hopefully at this point, it's making more and more sense as to why you're doing it. The biggest thing that I wanted you guys to take away from last week was an understanding of how to define and declare and invoke functions. I wanted you to understand local variable scope. With those two things being understood, we now have the understanding that these functions are like sealed black boxes.
You can't see out.
And we can't see out of them unless we give ourselves an address. I do know where Nina lives. Dang it.
Oh.
But that cute little puppy that was playing in the road, I don't know where he lives.
No.
And what if I wanted to deliver that puppy a treat? I need to know where he lives. Well, I mean, granted, I could walk into the road and give it to him, but I'm not going to risk getting run over by a car, so I need to have an address for where he lives, and then when he gets home, he can have his nice little treat. But I need the address. I mean, my analogy actually made much more sense when I was talking about putting mail in somebody's mailbox. If I wanted to put something in Ashley's mailbox, I don't know Ashley's actual address. I live in my self-contained unit. She lives in her self-contained unit. But if I had that address, I could physically go there and put it in her mailbox. It's the same thing. Ladies and gentlemen, that concludes our conversation about pointers. Okay, maybe we should talk a little bit more, but that's it. It is that simple. And I don't want you guys to get overwhelmed with, oh, good gravy, this is so hard. So, how do we go about creating our own pointer? So, we've seen how we can set up a variable called x and how we can initialize x to 32. Let me do this. I'm going to come in here, set my opacity back up to 10, maybe take that down a little bit. There we go. So let's say I want to create a pointer. Well, two operators that we're going to be using when working with pointers are going to be the Indirection operator and we're going to be using what is actually the reference operator, but it is generally referred to as the address or address of operator. So let me just put a little dash in here like such. So the asterisk was the first thing, the ampersand was the second thing, and again, this is our, I'm just going to say address of. Again, that's a very common thing that people refer to it as. And, okay, a question that just came in from Terry, and that is, when we did this right here, the address of, this right here, the address of x is, he's absolutely right, 0x5f. Okay, so very good. And what do I mean by indirection? It's going to make a lot of sense in just a moment. First thing we need to do is we need to use one of these operators, and we need to create a pointer. So the first thing in creating a pointer, it's still a variable. It's just a special kind of variable because the variable is holding an address in it. So if I'm going to point to an integer value, what type of pointer am I going to be creating? An integer. Very good, Mandrill. Outstanding. That's right. I need to match these guys up. So I'm going to say int asterisk p. This has just created me a pointer. Guess what's in here right now? Give it to me. Give it to me in BuzzNet. What do you think's in here right now, Nina? Based off the lovely code I've written on the screen. Oh, Mandrill, nice try, man. You just did great telling me. Garbage. That's correct. Self-coder, it's an address, but since it's not an address of anything of specifics to this application, it is garbage. Yeah. It's just garbage. We don't want to say nothing.
Oh, okay.
We got to be real careful because we're going to be dealing with null in just a minute, and later on tonight and a whole lot next week, we're going to start dealing with nil. Okay? Nil is when we get over into Objective-C. We're still in the world of C right now.
So it's garbage.
So right now it's just garbage. Yeah, it's just garbage, as Stealth Coder just said, means some random address.
Okay.
But since it is nothing that is meaningful to us, that makes it garbage.
Okay.
Now, once we get over into Objective-C, the specification for the Objective-C language is when you create pointers, they do get initialized. When we create variables, they do get initialized. But we'll be covering that a little bit later. So right now, I've got two variables. X has not been initialized. So if we wanted to make this look accurate,
Yeah.
we can just do this. So what's in there right now? Blah, garbage, and big brushes. All right. So now let's go ahead and we saw that we can assign a value to X easily, but watch this. I want my pointer, P, I need to initialize him, and I'm going to go ahead and initialize him to the address of X. What do you think I need to type to finish this line?
The 0 times 5f?
You think I need to actually type
Or X
0x5f in there?
Probably not. Star P?
Star P?
I don't know. Oh, no.
Okay. Well, all right. Look over at BuzzNet.
Oh, and X. Okay.
That's right. Because
Ampersand
if you
X.
think about it, I said it. I want to assign
I
to my
failed.
pointer P, I want to assign the, check it out. Watch how this works. This is so cool. The address of X.
That makes sense. Huh?
Remember what this is generally referred to as? Pretty cool how that works if you think about it.
Bless my heart.
And Terry asks if you can write int asterisk P terminator, and the answer is yes. This is the workflow that I use, or the convention that I've always used. So, but the answer is yes. Now, I got once again, I don't get to what the indirection is. Well, you better not. I haven't talked about it yet, darn it. But just for you, I shall talk about it now. Watch how this works. Let's now put 32 into X, but let's not do it with X. Let's do it indirectly. Get it? Indirectly. Indirection. Here's how we can do it indirectly. We can use the indirection operator. I can come down here and I can put my asterisks in here. Used in this way, the asterisk is now referred to as a dereferencing operator. So you can look at it as having two meanings, but in the end, we just always just simplify it to pointer. But it is an indirection operator / dereferencing operator. So to dereference that address, I can say asterisk P equals 32, terminator. The compiler sees this when the compiler is compiling this, and the pilot, that's awesome. The compiler, I have no idea where I got pilot from. I'm just in the mood to go flying right now.
Piles it.
When the compiler sees this, the compiler goes, oh, we're using an assignment here? He needs to dereference this. To dereference that, what is in P? Because right now, I'll draw this out up here, and I'll say that this is P, and then we know that this one down here is X, okay? In P right now is this, which is a pointer. So this guy is pointing to this address, which is holding that information. Okay, does that make sense? Why is it holding this address? Because I told it to on this line right here. Before I told it to on this line, we just had a garbage address in there. We just had garbage in there. So now, by telling the compiler I want to dereference the address that is in P, so basically that allows me to look at the actual memory address. And can you change, all right, I just looked over on BuzzNet. Great question that came in over there, asking, can you change a local variable in another black box function by using this? Yes, and that's what we did with scanf earlier. We changed a local variable back in main in the little example by passing the address of that variable into the scanf function. So now scanf knows where X lives, man. Think about it. If a hitman's going to go out and do a job, he needs to know where the mark lives. Once he knows where the mark lives, it's all over. So, very, very simple stuff. I mean, it is really this straightforward. And people turn this into a really big deal. So let's go ahead and jump over real quick into Visual Studio. Xcode. I was just kidding there, ladies and gentlemen.
Messing with you.
And let's come up here and say int x terminate. And now I want to say int, and how do we make a pointer? We use our Indirection operator, p terminator. And now what I'm going to do is I'm going to come down here and I'm going to say that p, now notice right now for p, I'm not using the dereferencing operator. What I'm going to do is I'm just simply going to say p, and if I just refer to p, now I've got to go to the bathroom. If I just refer to p like this, I am saying that I'm going to be putting an address in here. So I'm going to put the address of something in there. We'll talk about initializations in just a minute. I cannot start doing this. Whoop, I already got some type of little pop-up saying, hi, how's it going? Variable x is uninitialized when used here. Fine. Let's say x is 32. I'm going to initialize it right here, 32. Aha. Look at line 10. We now have a warning from the compiler saying that incompatible integer to pointer conversion assignment from an integer pointer from int. And it's being really sweet if you think about it. It's saying, please, well, all right, I'm adding please, and please take the address with the ampersand. So you can be like, all right, geez, if you really want that, I will. Oh, hey, what do you know? Shut up. Stop complaining. So at this point, we have simply, well, moved our terminator to New Mexico. So at this point, all we've done is defined a memory location that will hold an integer value. Then we have created another variable that is an integer pointer, which will be pointing to a memory location that is the size of an integer, that is designed to hold an integer. Then I went in here and I said, all right, well, let's take that integer pointer and let's assign it and let's read this out loud, everyone, the address of x. Say it again. Say it with me.
The
address of x. Because I didn't do anything fancy with my p. Ooh, wait, that sounded horrible. I did not process it ahead of time so that it was clean p. Just kidding. Just kidding.
Just regular old p.
That's right. It's just regular old p. But if I wanted to, I could come in here and manipulate p so that we could indirectly do something. So let's have a little bit of fun for a second. If I wanted to come in here and print, so I'm going to print out the value of x equals, and give myself a number, and let's come in here and let's just print out what it's in x. And let's new line this baby. New line. So I'll go ahead and run this. And we can see that the value of x is 32. Well, that's pretty straightforward. We've all done that, you know, a million times, other than you putting this pointer stuff in there. Let's try something else more interesting. Let's now come in here and say, I want to indirectly change the value of what is in the address we're pointing to. Okay, that's a mouthful, but it's not complicated. Think about it. I want to indirectly change the value in the variable we're pointing to, in the memory location we're pointing to 76.
Oh.
I'm not going to change line 14 at all. I'm still saying the value of x is, and whatever is in x. If p is pointing to x, and I just said indirectly change x to 76, we better print out a 76 there. And I'm going to go one step further. I'm going to copy this line, and I'm going to paste it above this indirect assignment of x, so that we get two of these guys printed out, and we can see what x was before we changed it. And then I just happened to look over. Jonathan said, so then how do we dereference it? We are dereferencing it here. That's why they also refer to this, depending on the books you pick up, as the dereferencing operator. So by dereferencing that memory location, we're looking in there. We're peeking in the window now. So let's go ahead and run this. Booyah. That's right. So P is the middleman. In this case, yes, it is. And I just changed X. You're absolutely right. But here's the key thing that I think a lot of people forget. We indirectly changed what's in X. So P is still pointing. So just this part, just this P. P is still pointing to the address of X. But by doing this, we're going to dereference that address, so that means we can indirectly assign it. Why would we want to do that? Well, let's jump back over to the whiteboard. And Mandrill, just for you, my good friend, I want you to give me another solution for scanf. In scanf, I need to change the value of something in another function. And I can't directly do it. Hopefully you guys are going to start seeing what I'm getting at here by saying directly. Ooh, I like that. Look at, who said that? Stealth Coder, you the man. I like that example. What I'm going to do is this right here. I can change that address of X to just P. And that still works. Oh, as Mandrill says. Very good. So you see what's happening, though. Let's go ahead and jump back over real quick to the whiteboard. And let's prove the addresses are the same. Well, we know they're the same because we physically saw the numbers to change. But just in case you ever want to play around with this yourself, this is kind of cool to know. So let's come down a few and do a printf. The address of X is, and I can come in here for one of my format specifiers and say %p so that I can print out an address. And now I'm going to come in here and I'm going to, what do you think I'm going to put here?
P?
I mean, first I could just put P, okay? But let's not look at P. We want to see the address of X, and I want to use X. So if I want to use X as the variable in which I'm going to pull the information from, Mr. Lewis has got it. Absolutely.
That's an ampersand.
That's right. We're going to use the address of operator. The address of X is what I want to show. So if you think about it, on line 19, I'm not thinking about P at all. I could care less about P on that line. I'm just saying the address of X is this. The fact that I'm actually using a format specifier %p, it's just so that I get this address properly printed out for me from the pointer. Or the address. Let me just say address. That has nothing to do with the fact that my variable is called P. I'll feel better now by doing this. Sorry, 1 second. Just, I want to prevent any confusion. There we go. So now, let's do one more line. Let's new line this bad boy. And go ahead and do one more printf and say the value in P is, %p, new line. Check this out. What do you think I'm going to put here? That's right. Very good, guy. Oh, Ray, my good friend. Oh, that's the start of the confusion. But nice try. You don't have to redeem yourself because you've answered 900 right. Oh, look at that. He redeems himself anyways. Good job. Oh, CBY is actually more correct than anyone because we did rename it to PTR. But you're absolutely right. For those of you saying P, that's completely acceptable because that is what we were using. But we're just going to say PTR. We don't use an indirection. There's no reason to use the indirection operator here or the dereferencing operator because we're not wanting to look at the value. Remember, this is what trips everyone up. We don't want to look at the value that is in PTR as far as the value meaning the address we're pointing to, the value that's in that address. We don't want to look at that. We want to look at the address that's just simply being stored in PTR. And that's what we're doing here. So I'm going to do one extra new line up here just to keep these two guys from becoming siblings, just to space them out. And we should see the address of X and the value in P as the same thing. This is a mandrel. This is a format specifier, %p, which will allow me to print out an address. Format specifier, well, take a look. Remember, in printf, we have our string, and if we have any format specifiers in there, like we've been doing for a long time now with %d, then we've got comma, and then we have to feed it something. Okay, you got it now. Good deal. So here we are. This is just a format specifier for this, for printing out. And no, Exion, it's not a string. %s would be string, which we'll actually use that later because I'll be mixing C and Objective-C together just for us to have some fun to show you that everything we've been learning was for a reason. Okay, so let's go ahead and run this. Check it out. We got some hex numbers down here that indicate actual address locations. And you'll notice that and this is so important to understand what I'm using here, my terminology. If you get this terminology down, home run. You've got it. You've got pointers. The address of X is this guy right here. The value in the pointer P, the integer pointer P, is the exact same address. But yeah, %p is just a format specifier to format what's coming in as an address. So we are now looking at an address that is the same as this. And because of that, we can now, that's why we were able to come in here and this is key here, indirectly manipulate X through our pointer. Oh, I love it. Let's go back over here and write down on the board. I love when you guys get involved and help me teach. It's so much fun. So, hello. Let's not be ridiculous. Why are we not wanting to? Oh, did I start at the bottom? Ooh, that was dumb.
Oh, no.
Why is it not wanting to? There we go. Jeez.
It's being naughty.
So basically, what Jonathan just said, he said, so if I did, and we're going to use just P again up here in X. So if we were to look at this, then we could say X is going to be just an integer value. Ampersand X is going to be the address. Very good, Nina. Of where X is pointing to, where we will store an integer value. And P is going to be holding the address of X because we assigned it up above, remember? And I really need to write it like this, the address of X. And then finally, to dereference P is going to be pointing to
The value?
an integer value
Yeah, value.
being stored in X. And I'm just adding that there just for extra clarification. Ladies and gentlemen, this is it. People. That's right, Brian. People. You got this. Honestly, it is this simple. Ooh, Mr. Lewis, I like it. P equals where, but dereference P equals what? What we're pointing to, what we're manipulating it, we're touching it, we're getting in there. But P itself is just an address pointing to a location. And that stealth coder flipped it. It's all good. If you want to look at it that way, it's a little more confusing, but you could, if you in your mind put like what address in, where that address is pointing to's value. See, look, man, you had it right. We just had to explain it differently. And I know for some of you guys who have seen pointers before, I am probably like really dragging this out, and right now you're probably tying a noose and getting ready to hang yourself, and I do apologize. But I just want to make sure that our real beginners in here, Brian, that our real beginners in here are truly understanding what's going on. Because this is at the very heart of everything you can do with pointers, everything. Like I said, I think we can have a lot of fun by doing a pointers workshop if you guys are up for it. We can do it in C, we can do it in Objective-C, we could do it in C++. And if you have a hatred for pointers, Ashley, get over it. Brian, go beat her with a floppy stick. That's the kind with the foam over it that you get at Walmart.
The wet noodle.
A wet noodle. No, that's not going to be any good. The floppy stick shall at least fill. Yeah, I agree, Exion.
Wet noodle's nasty.
So that is it again. Understanding just these concepts. Now, there's one other concept that I'll be introducing very shortly, and it was not something that we needed, but that is actually using void pointers. But they're cool. So Jonathan is saying if asterisk PTR is dereferencing, then does that mean at this point it will no longer be a memory leak? Ooh, hoo, hoo, hoo. Everything that we're messing with right now is a value type. Our pointer is pointing to a value type. We're not leaving the stack. Remember this sexy place up here?
The stack.
Everything that's going on. So here's a close-up of the stack. And this little basic example, and I know, Jonathan, you completely picked up on what I'm saying, but you did bring up a good point. I want to make sure other people understand this. So here, what we're looking at right here is just this stack frame. So this is the stack frame for main. I've just blown it up and made it larger for you guys. So here's X at the value, or at the address. Let me do it like this. This might make it kind of cool to see. At the address of 0x5f, and in it we put a 32. Here is our pointer variable, which is at, what address is it at?
It's at the...
Mr. Lewis has redeemed himself beyond redeeming himself. We shall pass him off the golden crown.
It's O.
No, Seaby, don't say sorry. I'm glad you jumped in and you know, you're trying. I just want participation. I love it when you guys participate. Its own address.
Oh, duh.
So it might be sitting down here at 0x60.
Err.
So he's at his own address. But what value is it holding in here? Based off of what I'm drawing on the stack frame here, what value is in here? That's right, Mr. Lewis. The value that is being held in here is 0x5f. I want to, but bear with me, guys. I want to draw that bigger, if you guys don't mind. Ooh, yeah, look at all that juicy room.
Yay. Lots of real estate.
It's the most crooked line in the world. But you know you like it. All right. This is on our stack. What is this box called? Quick, give it to me over there. This is called our.
Wait.
This is our. Address is higher, go lower. This is one box. It is called our stack frame.
Stack frame.
I'm just going to get you guys to start using terminology if I have to get Mr. Bull to go shock you. This is the stack frame for what method are we dealing with, ladies and gentlemen?
Stack frame.
What method is this stack frame?
Pointer.
He belongs to main.
Oh,
okay.
main. Oh, gosh.
That's
Darn
okay.
it.
All right.
Yeah, we're in main.
So in here, I'm just going to say, actually, let me do this backwards. Hang on. I think this will make more sense. Watch this.
Okay.
Address. Identifier.
Oh, we did that before.
And then the value that is actually being stored there. So remember, every time in the past that I was saying, you know, we've got a variable that's x, it holds an integer value. It's kind of like a box. And when we say x equals 12, what we're really doing is taking 12 and we're putting it into x, putting it in the box. This value side over here, that's the box, okay? Everything else there, that's not us. Everything else there is addresses that our program is handling, the identifiers that we assign. So only value is values that we can manipulate. That's right, Scion West. The CPU is handling that stuff. We'll keep it simplified to just that. A little more complicated than that, but yeah, basically. So we had started out I'll just say int x equals 5.
Okay.
So I guess I'll be counting, well, I'll count from high down, so I'll count backwards. So there's the address. That's handled by, again, CPU. This is just a memory map. The identifier, the friendly name is x. And the value that is actually being stored there, this is what we actually got to touch, is 5. So now we came down here and we said, all right, well, I want to point to that because, by goodness, I want to send this variable off to some other function and let that other function manipulate it. Without pointers, I cannot do that because we all know that our functions are sealed like Fort Knox. They're like lead boxes. So we have to let somebody inside of that box know about the address of somebody else in a different box. So I know the first thing that I need to do if I want to be able to change x indirectly, I need to get the address of x. I need to store it in a pointer. Of course, I don't have to make a pointer right here. I would make the pointer on the receiving end of a function. But let's just, to make things simple here. But I know that the pointer is going to be holding a value, an address value, that points to a specific type. And that's what's really important here, is it's got to be to the right type. And I'm sorry, that was just like driving me insane. So I'm going to make a pointer an integer pointer. Using my indirection operator, I'm going to call it P, and I'm just going to leave it garbage at the moment. We're going to talk about initialization in just a second. So this line right here, so let's say this line is now being executed, if you will. What happens is now at 0x5f, I'm counting backwards in hex, we now have the identifier P. And what's in P? Well, as we heard
garbage.
earlier, it's garbage. Look at Nina's rocking all over this now.
Woohoo.
Getting it. Good deal. So right now, there's definitely charges and no charges in the little bitty tiny baby capacitors in the memory. It's got something, but it's just garbage. And now what we do when we come down to the next line, we want to work with P. Seaby asks real quick in BuzzNet, he says, garbage means it is empty. No. Garbage means that there's data there that is irrelevant to us. So if we operate on that data, that's irrelevant data that we have nothing to do with. If we operate on that data, utilize that data could be pointing to a memory location. Well, it would be. God only knows where. So we don't want to do that. We have to initialize first. So now when we start using, and Nina just wrote a great note down that said X is in the witness protection program. It really is. It is.
And we don't, because they don't know a D address.
I like that.
It's in witness protection.
That's very cool. So when we start using our pointers, we've got to ask ourselves, what are we wanting to do with the pointer? And it really is this simple. Are we wanting to use it as a memory address holding device or variable? Or are we wanting to use what is in it to indirectly gain access to what it's pointing at? So I think a lot of people get confused there. When they start using pointers, they don't stop to ask themselves, well, what do you want to do with it? So yeah, again, the question is, you ask yourself, when you're going to use a pointer, what are you going to use it for? Are you going to use it for the address? So do you need to actually do something with the address itself? Or do you want to use it for indirection? Indirectly affecting something. So why would you need to use it for address? Jonathan, I need to use it for address right now to initialize it. P equals the address of X. Terminate. So by doing this right here, to finish out because we've just initialized P. So what is now in value over here in the stack frame?
5. No, wait. X.
Jonathan, you got it, my friend. We have 0, X.
Oh, the
well,
address.
wait a minute. Hang on, back to Scion. Yeah, he got it right. My brain just told me that maybe he was talking about the other value since I swapped them.
Wrong box. Okay.
That is what is now in. That's what's in the variable P.
Because P equals the address of X. Okay.
So
which we know.
You guys try to grasp that one.
I get it.
That's P's value. That's right, Jonathan. The value that is, as you see up here, the value that is being stored in P is an address.
Okay.
The value that's being stored in X is an integer value. Okay. What's really awesome is if you want to be more specific, this is really important, but not so much to you guys at the moment, but just in saying this properly, the value that is stored in P is an integer address. It's an address pointing to an integer variable. And that is important because if we had an address that's pointing to a char, it's going to look a little different. But let's not get into that. That's more towards for advanced pointer stuff that has no bearing on anything we're going to be doing, actually this class or the next. Yep, wrong size and type. Sizes, we got to match our types up, the number of bytes that we're going to be using. But like I said, that's getting out there a little bit too far. We don't need to go that far. You don't need to even know that. You don't even know that to become a pointer expert. Just as long as you know that what you're pointing to, the address of what you're pointing to, you need to make sure that the type matches. If the type doesn't match, and let's say that, because right now we're just dealing with, a little integer, but later on we could be dealing with a structure that, has a memory address that this structure basically could be holding a couple of ints in it, and then it might hold an array of characters in it, then it might hold a float, and then it might hold whatever. So I need to make sure that my pointer, in this case, knows that if I want it to point to this structure, yeah, and are structs types in C2? Yes, they are, Jonathan. But I need to know the type that I'm pointing to. So it's important for everything. Now I'm gonna show you some crazy stuff very, very, very shortly here called void pointers. And void pointers don't have to know what they're pointing to. But we're going to get a little taste of casting, and it's going to look all confusing. And Brian's going to curl up in a ball on the floor, and he's going to cry. He's going to weep like he's never wept before. Well, except for last weekend. And Ashley's going to have to go over, and she's going to have to make him feel better. And I'm going to feel bad. It's okay, Brian. Just know I've got your back, man. So we'll get to void pointers in just a minute. But this really is it. I mean, it's just this simple. Void pointers are, yeah, Jonathan, yeah, like ID. I don't even like saying that out loud. Because some people are like, what the hell are you even talking about? What's an ID? I'm leading this class. How many people have we lost? Hey, we haven't lost anybody. The number went up by 1. Sweet.
Yay.
Welcome, whoever joined in. And thank you guys for all hanging out. This has been fantastic. I love teaching these classes. They're so much fun. Got an ID? Out what? We'll be getting to IDs a little bit later. Because next week, I want to cram in a whole bunch of new stuff that I was not originally planning on putting into the Objective-C course. Like getting into writing our own initializers, basically our own constructors and all. So I just thought it would be like awesome to cram more into tonight so we could cram more into tomorrow. Or next tomorrow, whenever, next Tuesday. Okay, so we all understand the difference that's going on here, right?
Equals address of X.
Regular variable type holding whatever data type we've specified, in this case an integer. And we're looking at a slightly more accurate representation of a stack frame now. We're still missing a few things that we would be holding and all. But in here, every single guy in here. So if we had, int y, let's say that I want to put, so y now gets put on there, on the stack.
Okay.
And its address is going to be 0x5e, counting backwards.
Woohoo.
And I want to put, I'm only allowed to use my pointer. And I want to put what is currently in X into Y indirectly.
So you would use that.
What would I need to do? Type it into BuzzNet. Nina, write it on a piece of paper. Stealth coder. All right. Come on, guys. Anyone? All right, Mr. Lewis.
Or wait.
Hey, no,
or
stop. Stop.
This
Don't. No.
No?
You had it right the first time.
Oh.
Nina, Lena, what are you thinking?
Oh my gosh.
I want to listen. All right. This is for my beginners. Listen to what I'm saying, because that's very important in understanding how to code. Is you got to know what you're trying to accomplish before you can code it. I want to assign Y. That means Y.
So Y has to go first.
That means Y has to go first because I'm going to be putting something into Y.
Star P. Or whatever.
And now the only thing that I can use is my pointer. So if I come in here and I use my dereferencing operator, in this case the compiler knows that's what I'm doing. then I'm pointing to the Ashley. What?
What did Ashley say?
Whoa, Ashley said y equals
Oh, that's not
pointer indirect x. No, ma'am.
Star P in.
Because, and that's okay. Let me see if I can find a way to explain what you're trying to tell it to try to do. But first, let's just finish looking at this. So y equals, let's jump back over here. And let's do an int y. And then let's grab this guy. Working on this little teeny keyboard that's way over here, so forgive my slow speed as always. And let's just print out whatever's in y. And let's initialize y. Y is equal to whatever our pointer is pointing to. Whatever value it is pointing to. So why did I say 7?
I was wondering.
I did not even realize that I did that. That's some crazy stuff. So here, let's just print out what is in y. Y contains a 76, just like we saw x get put in there. Okay? So you see how we can use this guy on both sides of the assignment operator. No matter where you're using it, when you do asterisks and the pointer, if it's not in a declaration, you're dereferencing it. You're now it's like you're putting on special goggles so that you can see into the world it's pointing to. That's what that is giving you. Okay? Hopefully that makes sense. Let's jump back over and take a look at what Ashley was saying based off of the stuff we've been talking about. So, as you guys have seen, in this case, what ends up in y, we've dereferenced y. So watch what's happening. We take this address and we look in that address. Looking in that address means this is the value that we see in the address. So y, since we dereferenced our pointer, y is containing the value 5 in this case. So that is correct. For those of you that said y is 5 is absolutely right. Now, Ashley had a great question. She was saying, well, couldn't you also do, let me scan back through, let me find it. Where's she at? Hunting.
Oh, gosh. Here.
Y equals dereference x. So just based off of what I've been talking about for the last 50 minutes, what is this saying? See, that's understanding what this is saying. Very good, Jonathan. Jonathan said that star x, and a better way to look at it, and I'm going to modify what he said just a little bit. X isn't pointing to an address. X isn't a pointer.
It's an integer.
So what we're trying to do, if you think about this, if the compiler wouldn't gripe or cause stuff to blow up or anything like that, wouldn't this be doing the following? Dereference. Oh, wait a minute. No, my bad. Hang on. I didn't mean to point it there. Dereference x as an address we're pointing to. That address is 5. Huh? 5? 5 is not no stinking address that we know of.
5 is a value.
But do you guys see what I'm getting at?
I'm looking at it.
I can't find 5 to access its value because, no, actually, please don't ever be sorry. Ever. This is, I want to, for anyone that has gone through pointers before and have some confusion to it, I want to try to make it as clear as possible as to what's going on. So I really appreciate these particular questions are the ones that I really like. Just dealing with this basic stuff right now. So, or and let me not say basic stuff. The foundation stuff for pointers. So I can't do this because X is not a pointer.
A pointer.
Let's just try it. Let's see what kind of fun we can have.
It's gonna
I don't try to
explode.
code that way, so let's just come over here and say, because the compiler better be like, hey, my good buddy, you've lost your mind. Otherwise, it's going to run and it will definitely crash on me. But it should stop me. I want to dereference what is currently in X. Look at that. Indirection. Yep, there's that word again. Indirection requires a pointer operand.
Integer is invalid.
Int is invalid. Because remember, it's not a pointer. It's not an integer pointer. This is an integer. There's a big difference. An integer pointer points to an integer variable location. Points. But an integer value simply stores an integer. So we can't do that. So hopefully that makes sense. You guys did really good at getting the at this guy right here. So hopefully at this point you're starting to see, okay, I see. We want to go in here and we want to make a pointer. Why do we want to make a pointer? Because we know we need to point to some other variable location. Why would we want to do that? There's several reasons. And some of them, the more complicated ones, I can't get to right now. Because it gets a little bit more involved. Like function pointers. If I want to be able to point to a function and pass that to a function, and have a function execute another function. Okay, hang on, that's good, too far off. So that's not. Or you can use pointer math to walk through pointer addresses if I have an array of things. Ooh, what? Huh? Array? Collections? I know nothing about that. It's not been in this class. You guys will be introduced to collections soon.
Major.
Again, more interesting stuff. But to understand any of that, you just need to understand these core concepts of a pointer. Jonathan, we will, that'll be reserved for the fun class. Okay? I've already got some people freaking out and like saying, holy shiza over in. And since I don't speak fluent German, I can say that, and to me it's just a cute word.
Yeah, that's right.
So anyways, which I said it before I thought, so sorry if that offended anyone. So moving right along. So let's go ahead and talk about what pointers can contain.
Pointer to...
And right now you might be thinking to yourself, what pointers can contain? Well, pointers they contain addresses.
Addresses.
Ooh, and Stealth Coder brings up a really fun one.
Pointer to
and
a
that's
pointer.
pointer to a pointer. And for those of you that are curious, that can go on and on. You can continue to chain that. So you can have a pointer pointing to a pointer that's pointing to a pointer that's pointing to a pointer.
Holy moly.
And yes, I've seen that done. And yes, it gets confusing because you have to flipping work out what's what. But let's not worry about pointer to a pointer because Mandrill just said what I was about to say, because you're going to ask why. And that's way outside the scope right now. So I'm missing C#. You can use pointers in C# too. You got to be careful once you start marshalling, working with unsafe code. Stealth Coder, it's a good question. Not for this class, but there are valid reasons why. We should have a class at some point. And that's a good point, Nelson. References are just pointers, which is true, but I mean, you can actually define pointers with the asterisks and everything. But let's get back onto this. So pointers can contain. Let me see if I can make a little bit of room down here. They can contain an address, And you may say to yourself, oh, garbage. Yeah, you can still look at it as being, it's an address, right? They can contain, I can initialize one with a pointer with 0. I can initialize a pointer with null. So these are the things that a pointer can contain. So what I want to do is jump back over here to Xcode. And let's start out by grabbing this line right here and moving it way up here and saying the value in P, which is now PTR, is, so let's run it. The value that's in PTR at the moment is showing 0 by 0. The hex address 0. So don't say to yourself, oh, geez, well, they're always initialized. I'm in good shape. Do not go with that. As far as I'm concerned, this 0 by 0 is just garbage because we've not initialized it. Now let's initialize it. Let's start out with 0. Let's run it. We know for a fact we've safely initialized it. Now look what we have in there. 0 by 0.
Oh, that's what I had done.
Now let's do one more. Null. 0 by 0. That's our valid nothing memory address. So those are 3 different things that you can use to initialize a pointer with. A pointer can be initialized with a memory address. And this is a valid memory address. A pointer can be initialized with 0, and a pointer can be initialized with null. Now let's try a few other things. Let's try some what I would call no-nos. So what if I tried to initialize my pointer to 5? Why is that invalid? That's right. That's a value. 5 is not an address.
Yeah, it's a value.
So this is just a literal integer. If I come up here, look at this. Compatible integer to pointer conversion initialization. The same thing a second ago. This is looking for an integer pointer. Notice the integer and the asterisk. It's looking for an integer pointer with an expression of type integer. Can't do that. So that's important to understand. We cannot do that. Which means we also can't do this, can we?
No.
No, we cannot do this. We do know that we can do
And
this.
Because that's the address
Because
of.
that's the address of. I just want you guys to keep this in mind at the moment.
Oh.
Hi, Mandrill. How you doing? Mandrill wants to go up here and type in 0x0 and run it. And it runs just beautifully. Compiler's pretty smart for the most part. But I'm basically, I'm initializing it with its address of basically null, of 0. And thank you for the all caps and screaming. That worked well for getting my attention.
Yeah.
Nina punched me in the arm.
Like, dead.
What is 0x0? It's basically null. That is the way that I've always treated it in everything I've done. And that works flawlessly. Yeah, it's an empty address. Okay, so that So I've been going like just over an hour now of just this very basic stuff. And let me see if there's anything that I wanted to cover on this page right here. We're on page 3 of 16. Sweet. Oh, I talked about that one already. Looking through, so we know how to directly assign. We know how to indirectly assign. I think we have really, you would never want to do what Mandro said, can we take an integer pointer and point it to 0x7FFF? You don't know what memory addresses the operating system is going to allocate for the program execution stack. You can't start trying to hard code addresses like that.
No hard coding addresses.
Because you run the program one time, and you're like, oh, okay, I use the ampersand to get that, and I know what the address is, and sweet, I'm just going to, for whatever reason, tie this in directly. But then the program runs later or on somebody else's computer. But self-coder, what I'm saying is you never want to put an actual, you don't want to do a magic number address because those numbers change from the CPU. Little values of memory addresses. I know, Jonathan, I'm saying,
but you
don't even play with that. That's dumb. I'm saying you would never, ever, ever want to do that. Period. So get off that subject. Never. That's dumb.
No.
No, I'm saying, you would never use literals with a memory address. You would never say this specific address. Because, Mandro, I'm with you, man. I know you got it. Jonathan's just like trying to goat me on here. I know what he's up to. He's giving you a hard time, Jonathan. No, I'm just playing with you. No, when you run when you run your program, remember the operating system is what's in charge of allocating virtual, because these addresses, these aren't the real addresses to those memory locations. These are virtual addresses that have been handed over by the operating system that map back through to the real addresses. So you don't ever want to go in here and start trying to start hard coding addresses. Okay, so with that, let's go ahead and take a quick break. When we get back, what I want to do is spend just a minute and talk about passing by value, just real quick. We've already talked about that over and over and over. And then let's talk about passing by reference using indirection, which we've already done. But I want to get that covered. And then we'll be moving on to void pointers and then finally part 2. So, oh man, don't be talking about pizza. That bums me out.
Me too.
All right, so we are now officially on break. You got 10 minutes, so go scarf down some pizza. Hello, ladies and gentlemen. We are now back from the break. The next thing that I would like for us to talk about is going to be passing arguments as we've looked at them before, and we've discussed this. So this is almost a review, and because of that, I'm not going to have you follow along at the moment because we've got plenty of stuff for you guys to do in a little while. I just haven't considered anything challenging yet. Isn't that great? We've made it through a lot of the pointer stuff, and I haven't considered it challenging. Okay, so what I want to do now is talk about, again, this is in its own way, this is like beating a dead horse. Ooh, that's horrible, but I know that's just a phrase.
Can we make that into an analogy?
I'm sure we could. Passing.
I mean, if I'm not offended, nobody should be.
True. Passing arguments by value.
All right.
Versus by reference. With the indirection operator. So remember, it's kind of a simulated pass by reference. I mean, but it is pass by reference, so we shall stick with that. So first thing I want to do is if we came in here and we did int x, this is in main, equals 0. And then I said, let's go back to the old basic days. I'll just do a P instead of a question mark. So this is pseudocode. So remember, everybody keep this in mind. So printf, and then in here I'm going to say enter a number. And then, actually now, just leave it like such. And then I'm going to come in here and I'm going to say scanf. And then %d. And for those of you that already know this very clearly, take your break. Again, this is, again, it's a heavy, heavy review for our beginners. So scanf, this is going to allow me to capture a value and store that value into X indirectly. See, we can start talking fancy now. And then what I want to do is I want to call a method called modify me. And modify me is going to take in X. And after we're done with that, we're going to do a printf and just simply say X after call equals %d and then whatever's in X. Okay. And if right now, function. Whoa. My apologies. No, thank you guys. I actually appreciate you catching me when I say method. Because we're going to be talking methods, nothing but methods once we move over into the world of Objective-C. So, all right, so all of this is in main. And then down here I've got void modify me.
That's right, because it doesn't return.
And modify me is going to take in an integer, and we'll just call it X. And then in here, I want to say that X equals 100. So we've modified it. And then I want to do a printf X equals, and then whatever's currently in X. And that is my program. Nice and messy. Now, we know that when we start this out, the stack frame gets created, we get X on it, and X is, so here's my baby stack frame over here. So here's main, X is put on it, and it's initialized to a 0. Then we print out to the console, enter a number. Then we call the scanf function, and we point back to this X right here, and the user types in 23. Then we execute the modify me method, our function, just testing you guys. So a new stack frame is created. His own X is created, and 23 is passed into it as an argument. Inside of this stack frame, while executing the modify me function, we simply take X and change it to a 100. But we all are now stack experts. We all know that what I'm doing is I'm changing the wrong X if I had intended on changing it back over in the main function. So then we're done. The stack unwinds. So that gets popped off the stack. We come back up here. Execution then jumps down to the next line where it prints out X after call is, and what is X? Everyone, quick, because we can see it. I've proven it. That's right, actually, X is 23. So modify me does nothing. Pool shark, yeah, 23. C by 100, go outside. If it's snowing. If it's not, call upon Rowdy Bull to shock you. All right. This is passing by value. A copy of the value stored in X was made in this new stack frame. Okay? So now let's say that modify me really did need to change that. That's how we intended for this to work. How would we do it? Well, we all now know. We all immediately know, oh, we need to use a pointer. So I'm going to change only a couple of things. So come over here so I don't have to rewrite the entire thing out. I'm just going to come over here and say void modify me. What argument should it take in? I want to be able to modify the value of what's coming in. So what do we take in? Wake up, people! Wake up, wake up, wake up!
Indirect.
The indirect? Yep, the indirection. We need to take in an integer pointer.
Yeah, a pointer.
Oh, no, we're still just declaring this. So we need to, at this point, it needs to be an integer pointer.
That star one. Yeah, that one.
Okay, so pulling in an integer pointer x, that means I can bring an address in here. And now I can modify that by using the dereferencing operator. So what line would I write to update my pass by value type so that I'm actually changing x back in the main function to 100?
Equals star.
So Nina said
What's that thing called again?
x equals what?
The little.
The indirection or reference?
Yeah.
Okay, so x equals star what? I'm just writing it.
I'm sorry, I'm probably wrong.
Okay, yes, you're wrong. Because what does x contain?
Fail.
Well, or better yet, and don't worry about it. Understand what you're looking at. As soon as you understand what you're looking at, you'll understand pointers.
You have to say what it is.
What is x right now? Not what's in it. Just what is x? X is an integer pointer.
So you have to define it, right?
X is a pointer. That's right, Seaby. It's already been defined, and we're going to be passing an address into it. We're defining it right here.
Okay.
In the parameter list. So, Stealth Coder had it right just a second ago. Very good, sir. The way that I could now change the value of x back in main is by indirectly. So if I say, let's take a look at the actual value back in the address we're holding, equals, and I put 100 in here. And then I say print out whatever is currently in x. Which even that, I'm going to have to print out that value. Again, I'm going to have to use my dereferencing operator. And then that's it. The only other thing that I have to change is what? I'll give you a hint. It's back in main. To make this program work, well, technically there'd be two things because there's going to be a prototype as well that would need to be changed. But let's stipulate I just changed that. So what is the code inside of main that would need to be changed? That's right, Rowdy. Good job. The function call, the actual invocation of the modify me. Because modify me right here takes what, or is sending what over? What is being sent as an argument to modify me? A value. That's right, Jonathan. An integer value. And very good, Mr. Lewis. We don't want to send an integer value because this no longer expects an integer value. This is what I mean by grasping and understanding what is the variable expecting, or what are we referring to when we're looking at a variable. If it's a pointer, are we referring to what it's pointing at? Are we referring to its actual address? So in this case, what I've just pointed to integer pointer x is expecting an address to be sent to it. So let's do it. The only thing I need to change in all of my code on the left-hand side would be that function call in main that says modify me. And what do I need to put in here? Thank you, Stealth Coder. As I was starting to look over at BuzzNet, I was thinking to myself, somebody's got to read my mind here and know I would ask it. I would need to put the address of X, terminate. So the address is what's going to be sent over here. So now, what's in just X? Inside of this guy, inside of this function, an address. Because look, I'm just referring to X as just X. But if I say asterisk X, I'm saying dereference that address, and who are we pointing to? And at that point, we're then, by doing this, we're now pointing all the way back to this actual X value-wise. So this is indirectly setting X back in main to a value of 100. And Jonathan said, why would you use a pointer parameter instead of just having a return value of integer and returning a new value? Ooh. It won't be too obvious here. It's a fantastic point, though. Even in the simplest of programs right now, weren't we doing a copy? When we were back on the pass by value, didn't we use extra CPU cycles to copy the value of this over here? And then you're wanting to use extra CPU cycles for shifting that information off into one of the registers, unwinding the stack frame, and then have that information then moved from that register back over into X. We're now using more CPU cycles. And Stealth Coder has a good point here. But are the extra cycles really that costly? No, not in extremely basic programs like this. But what if for some reason we were dealing with updating a database with 1 million records in it? Directly touching the memory location is, or on a handheld device. So this, it would definitely be much more efficient this way. And again, there are other things that you can do with pointers that we will talk about in a workshop that gets even more interesting, but are really way outside the scope of what you guys need to do to get into iPhone and iPad development. So real fast, let's just take a look at these two things just so that we have all verified that it works. I'll leave one of the prints in there that I can just steal here in a minute. And what all are we using here? Just int x, and we'll do an integer pointer, PTR. And then up here, let's go ahead and say that we want to prototype out a void modify me that is going to take in an integer x. And then we need a void modify me integer x that is going to take and print out. What did we do back over in the other one? Yeah, that's right. We said x equals 100. And then we're going to do a printf and say x is bootaloo, x is equal to %d \n, and then we're going to say whatever's currently in x. And then when that gets returned back, I'm waiting. Now what we need to do is come back over here and call I'm going to go ahead and say that PTR is equal to the address of X. And then I think we said that X was equal to some number. I'll just say 63. And then we need to get out of Objective-C programming mode real quick. Hang on.
Oh.
I was waiting to see if somebody was going to say that. But we'll be switching over to this mode shortly when we get into Objective-C programming. And then put a terminator here. And so then I printed out the value in X is, and we're just going to print out that was funny though. The way I was prototyping that out, the way I was writing the function, I was actually in my head already switching gears. Isn't that cute? Okay, so same thing. So we're basically saying make an integer X, make an integer pointer, put the address of X into our pointer. So we've initialized the pointer. Then we're saying X equals 63. I'm not even doing anything fancy. And then the last thing is going to simply be calling modify me and passing what is in X. And then when we get back, seeing what we got out of it. So let's go ahead and run the program. And you can see we have no prints before line 14. So we come down here, we set X to 100, the local X, to modify me. Then we print out X is 100. Then we're at the end of our function, so we unwind the stack. We come back to the caller. There's nothing else to do on this line, so we go to the next line and we say print out the value of X.
And then that's when it's 63.
We're back into our original stack frame, and the value of X is still 63. We haven't changed it. So it's pretty much exactly what I wrote out over on the board. But let's say that we're looping through or dealing with a lot of data and we didn't want to copy. We didn't want to do a whole bunch of copying. Instead, what we want to do is just directly affect it back. And we saw that we could do that by simply, I'm going to come up here and start out by changing this to my prototype over to an integer pointer, updating my definition of modify me to an integer pointer. And then from there, I need to come over here and send the address of X. And now, when working with X, we know inside modify me, X is a pointer, so it's an address. So we need to dereference it to deal with it as far as values go. So I'll go ahead. Ooh, man, Mr. Lewis, you have yourself a good night, my friend.
Good evening.
Late for you. All right, so now let's go ahead and jump over here. Do the same thing. You'll notice I've gotten rid of all of my warnings, errors. Now if I run the program, so remember before it was X equals 100, the value in X is 63. Run again, X equals 100, the value in X is 100. Okay, so this is a pass by reference using indirection. Any questions? This just about the basic concept of what we're doing here. I think at this point I've smacked it around pretty good. If at some point later you guys come up with questions related to just the basic foundation of how we use this stuff, let me know. Just the big thing is to remember, anytime you're dealing with a pointer, you've got to ask yourself, in what way am I working with the pointer? Am I working with the pointer through indirection back to what it's pointing to, so I can manipulate the actual values? Or am I actually working with the address? So keep that in mind. Okay, so with that now behind us, the next thing that I would like for us to talk about is void pointers. And this is just for a minute. This is just to leave you guys going, oh, that's kind of cool. So let's jump in here for just a minute. So over into Photoshop and function F7. Let's go ahead and give ourselves a clean palette, and let's hide this guy out. And function F7 to get that guy away. Let me grab a pen real quick. And let's jump all the way up here. There we go. So now we're starting at the top. So you guys will end up digging through other people's code at one point or another. So let's go ahead and take a look at this because you're going to end up seeing it. Void pointers. A void pointer is really cool because it allows us to pass to a function or even work with a single variable that could be referencing different types. Up until this point, wait a minute, Jonathan, let me back up to what Jonathan just said. Well, he's saying pass a argument as a reference using indirection. That's correct. So it's simulated pass by reference. And I was just looking at the questions. Apologies. I'm trying to make sure I keep BuzzNet as up to date as I can as well. It's just hard watching all of the screens. So it's passing an argument. You can only pass by value, but if we're passing the address to a pointer, then that pointer can get back to it. So it's kind of like simulating pass by reference. Okay, so void pointers. We know that when we come in and we start creating pointers, we have to give a type. And then our indirection operator and our identifier. But what if I had, let's take a look at this. What if I had an integer, I'm sorry, I'm picky. What if I had an integer x that contained 12? And what if I had a float y that contained 32.68? And I want to make one pointer, but I want the ability to point to one or the other. So this is how I would define the void pointer. And at this point, just so that there's no confusion, let me get rid of this guy because I'll use P again. Okay, so now just simply came in here and said, we've got a pointer. It's going to point to a memory address, but we don't know anything about the type that's being stored in that address, which means we're going to need to tell the compiler. We will need to be aware of what type we're working with. So let me demonstrate how we can initialize this guy. So let's say we want to look at X. So if I was to come in here and say that pointer equals the address of X. So far so good, right? I haven't done anything crazy with that line on blue line number invisible 22, wherever this is right here. Nothing confusing there, right? I took the address of X and put it into my pointer. At this point, that's the only thing that matters. I haven't gone to use it. Let's use it now. One example of using this pointer would be an indirect value assignment. So let's use P to assign a different value to X. All right, guys, hang on tight. Let's just say that, well, I'm going to work my way backwards. I want to take P, and in X, basically, I want to assign, what number did I say? I want to assign 83. Sounds great. Okay, so the first thing you might be thinking is, well, we can come in here and we can dereference P. But the compiler doesn't know what we're wanting, it doesn't know what type P is. P's void. It's void of type. So what kind of memory? We don't know. So we need to tell the compiler what type. So dereferencing, as we're doing here, is absolutely right if you thought that, but we've got to cast first. So first thing I'm going to do is I'm going to put that guy out here because we're going to stick something in here. And you guys may have seen where we did the cast before, when Nelson was talking about just very simple casting on week number 1 near the end of class. I need to tell the compiler what type P is. Well, what type are we wanting P to be right now?
An int.
Ooh, very good, an int. But you're almost all the way there. An integer what? An integer pointer.
Oh,
Because P he's a pointer. So it can't be just an int.
It has to be an integer pointer.
We want it to be an integer pointer. So if I come in here and I say int pointer, now we're casting this void pointer to an integer pointer. And then using the dereference operator out here allows me to now properly dereference P, which is containing the address of X. So now I'm actually looking at X. Okay? And then the same exact thing applies for if I wanted to say, I could turn right around on the next line and say P equals the address of Y, which is now a different kind of address. So we've got float. And so if I want to dereference this to put something in there, no, I have a better one. I want to print out what the float is. So type into BuzzNet the printf line that I would use to print out what's in Y, but I want to use my pointer. And Stealth Coder, good, but you could change it up by changing the I for me. Then it'll be perfect.
Oh, shoot.
Just so that we get the floating point number showing up. The format specifier for float is just going to be a %f. Yep, correct. And then, like I said, so Stealth Coder got it. Very good job. I just want the format specifier to be of the type here, which is float. And so...
Blah, 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 %f. Oh, wait a minute. Wait.
Oh, you're right there at it.
Oh.
And for some reason, Exion suddenly made his P a capital P.
Wait, because, okay. Is that it? I knew that's terrible handwriting. That's a %f, believe it or not. And that's an end quote.
And then you need to dereference outside of, all right, there's,
okay.
Watch this. So here's what you guys would be looking for.
Oh, I need my dereference out that. So
you
it
need
printf.
Gosh,
okay, I'm starting over.
Let's say Y equals %f,
blah,
and
blah,
then
blah.
new line, comma, and now I need to dereference my void pointer.
I'm not looking at
To dereference my void pointer, I now need to come in here and say, we're going to dereference, and I need to cast it over to a float pointer, my void pointer P.
So that's what I did wrong. I didn't do.
Okay. There you go. Yep.
Okay.
Just like that. This is just planting a seed for later. We're not going to be using void pointers right now, but and this is all I wanted to talk about because this is outside of the scope, but I wanted to show you that such a thing exists. Maybe not 9 months later, Jonathan. I've covered a lot of stuff in just 3 weeks. or 2 weeks and 2 days.
A baby?
Yeah, really. Very good. I guess that's what he was joking about. I'm so slow. All right, so that's going to wrap up the discussion.
Ashley.
That's going to wrap up the discussion on pointers. I hope that at this point you guys have a good feel for what pointers are. Very good. Thank you, sir. As quick as you are knocking out all the answers, I feel like you've definitely got an awesome handle on it. And that is part 1 now complete. Woo! So part 2, no time for a break. Part 2 gets us into an introduction to object-oriented programming. And I know Nelson's supposed to talk, but if you're not bored listening to me, I'll talk for a little bit longer. Let us go ahead and come over here to a new whiteboard. I'm gonna let you talk in just a second. All right, Nelson, you got your whiteboard ready? Yeah, like Rowdy said, come on, Nelson, hang out. Give us some awesome talking stuff. He's like, oh, let me reconnect, and I need to jump back into BuzzNet, and I'm no longer in the GoToMeeting, and I'm drawing a pony.
A gun.
No, I'm drawing a gun, actually.
For his pony.
Pow, pow. Your whiteboard looks blue.
So while Nelson is... Are you ready?
Pony gun. Ha ha.
Yep, I should be good.
So Nelson, you can see my screen, right? All right, so follow me for 1 second. Intro to OOP, Object-Oriented Programming. This is part 1, because we'll get into things like polymorphism starting next week. I'm just saying this so that Nelson knows what I want to make sure gets talked about. I need to talk about what is it? Why would we even want to do this kind of programming? We need to talk about what classes are and objects. And I'm talking, Nelson, from a high level, because I'll get into the syntax for Objective-C here very shortly. I want to talk about class variables. I want to talk about methods. Notice how now I can say methods. Whew, thank gosh. And I want to mention instance methods. And class methods. It's very important that we talk about encapsulation. We need to discuss the basics of just with boxes and encapsulation. Thank you for pointing that out over there. We also need to look at inheritance. And that's the basics, because we got to use inheritance because we're going to be taking advantage of, everything that we're going to be creating over in Objective-C is going to derive from NSObject, and there's a few things that we get from NSObject that we're going to be utilizing. So I want to make sure that they at least understand the concept of what it is. So with that, Nelson, you're still there, right? All right, I'm now going to switch over to your screen because you see what I'm looking for.
So all of that?
Yeah. 45 minutes? Yeah, piece of cake.
Okay, but I just want, what is it? You just want me to get the overview?
Yeah, and you can use your whiteboard to draw out little boxes of like what a class is and what an object is. No coding. There's no coding at all. It's just concepts.
Sounds like fun.
That's why, guys, I'm saying that this should be nice and easy. It's just concepts.
Look at.
Okay, which screen are you guys looking at?
Blue screen.
Awesome. Okay, let me get my cables Oh, look, there's a gun on my desk. It's in my way. Put that down. Okay. So, OOP stands for Object Oriented Programming. Okay, so we've already seen with C, we've seen what's called procedural programming. Procedural programming is when you use functions to kind of guide the execution or the flow of the program. So you might start off with a function here, like let's say this is main. And then you might branch off to another function, and then that function may have some other function calls, and then eventually execution gets returned back to this function, and then this function then jumps back up there, and so on and so on. So procedural programming is all about procedures. Procedures are synonymous with functions in the context of other languages. So we've all been thinking about our problems procedurally, but it turns out that's actually not the best way to think about programming. There's a variety of other what are called programming paradigms that we can take advantage of. And the important thing to understand about programming paradigms is they are not about the language. They're about how you program. That's the most important thing to understand. So when I talk about OOP, I'm not referring to anything that's specific. Now Jason will be, because he's going to get into the implementation. But I'm not referring to anything specific to Objective-C. OOP as a concept is basically a way for you to look at a problem. Instead of looking at your problem like this, we make it a little bit more complex, but on the flip side, a lot more powerful. So I'm going to nuke these horrible thingies and talk about what's OOP. OOP is about objects. So we have functionality that we know how to call, functions. And that isn't, they're not very powerful. Now they are powerful, obviously we've been discussing them and we've been talking them up quite a bit, but what we want to instead think about a program as are objects. An object is state and behavior. That's all an object is. An object is a variable. So it could look something like, now I'm going to be writing out something that's going to be pseudocode that's going to be relatively cross-platform or cross-language. But instead of, I know I'm kind of jumping around all over the place, so sorry, but let me get this definition out, and then we can turn this into more of a discussion. But what we want to do is we want to define our program in terms of the objects that the program contains. So for example, let's say we have a program that deals with product inventory. So we have inventory. Now, what are some of the objects that we might want to have in this inventory? Well, we might have things like products. We might have things like customers. We might have things like orders. Stuff like that. Those. Sorry, I've been drawing for a little bit, and my brain is completely focused on the R mode instead of the L mode, so I'm having difficulty articulating myself. What we have are different objects that we can use to interact with our program, and each individual object contains state and behavior. So traditionally, we might procedurally write out our program, but what if we could take chunks of our program, kind of like what we did with functions, but turn them into sort of abstract them out into objects. So we have O1, O2, and these contain variables and functions, or state and behavior. That's an important thing to understand. State equals vars, behavior equals functions. So state and behavior, that's all it is. So an object has stuff, it knows what state is in. And the important thing about that is that different objects can have different states. So for example, a product might look like this. Product might have the following state, such as color, size, weight, price. It might have behavior, such as stock, purchased, set on fire, just for Nina.
Yay! Fire, fire.
So this could be our product object, and it contains all this state and behavior, and it contains all of this stuff. Hold on.
You okay?
There we go. It contains all of this stuff, and it can package it all up into what's called an object. So for example, we might have something like int main and int main might say product p equals something. We're not going to go over what the something is. And again, this is language agnostic code. The Objective-C syntax will look different. But that product p, this object right here, if we zoom in on it, looks like this. Now that object packages all this product stuff with it. If we were to create another object called P2, and again, what goes here is irrelevant to the discussion, it will also package all of this. But the important thing is that P1 and P2 are separate objects. They're both products, sure, but they're completely separate objects, and we can do different things to them. Like, let's say we wanted to set P1 on fire. I could go ahead and say P, and then I'm just going to throw in a dot because it's more similar to our languages. Again, if I'm getting too much into the syntax, Jason, let me know, but this isn't what it's going to look like in Objective-C.
I'll let you do your thing, and then I'll add in a couple of my own things for this. That'll maybe help. Okay.
But the idea is that what we're doing here is we're setting this on fire by telling it to be set on fire. We're not impacting P2. So the idea is that we can take our program and we can separate it into these different objects, and each of the objects have different state and different behavior. And when we design our systems, if we think about our program in terms of different objects communicating with each other through different state and different behavior, then our programs become a lot clearer and easier to understand. An example could be, for example, or I use the word example a lot. So let's say I have, this is an actual example of something that I did a few days ago, actually. I wanted to, I was working on a website, and I wanted to be able to have functionality that looked at a directory of files. And so there's a bunch of different files, and I wanted my code to pick out specific files and collect them. Now what I did was I wrote the code that went ahead. It was just a function. So I had a function. And then I also had variables. So here's my function that did different things, and then
Control D.
No.
Command D.
There we go. I had my function that searched the directory, return files. So I would have my, let's say, my int main said something like files equals search. And then I would have another function. So this is function search. And then I would have function pack. So then I would have another function that packed the files, returned single package. So then I would say pack equals, I don't know what that is. Is it Alt-Control-Z? Here we go. Pack files. So I had something like this. And that worked all right until I needed to do this for multiple directories and do this for multiple types of files. So what I did was I used the concept of object-oriented programming to abstract away this variable, this function, and this function into an object. And so the object I call bundler. And what's the state that it contained? It contained the files that it searched for and the packed file. What are the functionalities? Search directory and pack. So instead of doing this, where I said files equals search, pack equals pack files, I did something like this now. I have int main. So I had I had a bundler, and this got CSS files, for example. And then I had another bundler for JS files. And now these, each one of these objects contains a copy of all of the state and a copy of all of the functionality, and they're completely independent of each other. So now I could, instead of having to repeatedly do files equals search, pack equals pack files, I could instead say bundler CSS files equals blah, and then bundler JS files equals blah, and I was able to encapsulate all of that behavior into a single object that I could reuse. So again, it's all about, an object is really just a complex variable, and that variable can be zoomed in, per se. So an object gets zoomed in to state and behavior. And that state and behavior is packed around wherever that object goes. So, stuff and things.
All right, can I take a stab at it for a minute? What?
Yeah,
I'm not saying you did bad.
Ooh, what happened?
I want to.
Oh, I'm saying I did bad.
I just want to do command 1.
State and behavior.
Let's go ahead and switch back over for just a minute.
All right.
No, I'm not. Hang on.
I really want my scrubby zoom though.
I got Scrubby Zoom on my Mac.
Maybe you need to restart Photoshop.
All right, you guys.
So did anybody understand anything?
No,
I know I'm getting booed.
I was getting the concept of it, I think.
I just want to simplify just a part of this, and then Nelson can add on top of that. But I want to, when doing object-oriented programming, we are able to model objects just like we deal with objects in the real world. In the real world, we know what a cup is. I'm looking at a cup right now, and I sure wish it had some coffee in it. But I've got a cup. It has a color. It's green. It has a weight. It has a particular weight to it, size, color. So properties of it. What kind of functionality does it have? It doesn't do crap. I mean, fortunately, it'll hold liquid, but all this cup is is just, as Nelson was saying, state. So I'm going to come up here, and I'm going to put cup. And over here, I am going to put color, size,
Weight.
and how about the weight's determined by the material that was used to make it? So I'll call it material. Now, this is, yeah, Nelly, go ahead and mute for me just a second so it just cuts a little bit of that noise down. All right, this, what I'm drawing out right here, is a class. This is a template. This is not an actual cup. This is a template for a cup. And that is critically important. Oh, and I'm not saying that, let me reiterate, I'm looking over at BuzzNet. Unless you guys are, if everybody's really good with what Nelson had said and don't want a different perspective on object-oriented programming, you know, then that's cool. I don't mind. Nelson did fine. I have a specific way that I always talk about OOP to.
No, they're just telling Nelson he didn't screw it up.
Yeah, Nelson, you didn't screw up anything.
They're not saying they don't want to hear your stuff.
I'll make this quick. So right now, what I'm defining over here, I'm just defining, well, a line. These are just my blueprints for cups. Or anything. So this is all my blueprints are going to go in there. So I'll say blueprints. All right. So cup. Let me think. What would be another? I'm looking at all sorts of different. How about a mouse? A computer mouse.
Objects. Okay.
So I'm just looking for objects on my desk. Now, a mouse does have state and behavior. It has properties. So we could have, let's say it has a shape.
Color.
Has color. It has number of buttons. I'll just say number of BTNS. And then it has functionality. So I'm going to actually divide this between, because Nelson did an awesome job of stressing the most important thing about object-oriented programming, and that is when dealing with objects. Objects have state and behavior. State are these properties. Behavior are the things it's capable of doing. You guys have all seen functions. A function is a block of code that is a task to do. It is a behavior that you can call upon. When I taught Nina how to wash dishes, when we go back to that example, that was an actual behavior that she now knows.
Burning up the dishes.
So do you now consider all variables state? Well, at class level, instance variables, yes. Local variables for a method, that's different. But we'll start breaking that all out here shortly. Okay, so mouse, let's just say it has the ability to connect to a computer. Let's say it handles disconnect. And it knows button push. And it would know what button was just pushed. Again, everything that I'm drawing over here on the side, these are all blueprints. What's a blueprint? It's a schematic. It's a set of instructions for how to go about building something. Sorry, I didn't mean to kill Nina. So blueprints for a car. We can follow the blueprints and we can build a car. We can follow blueprints for a house. We build a house. We follow blueprints for a cup. We build a cup.
Build that cup.
So our blueprints, these are our classes. A class is a template for an object. So it's just a blueprint. It's a set of instructions about it. If I was to instantiate, that's a word you guys are about to start hearing a lot. If I was to instantiate a class, what I am doing is I am actually taking that class and turning it into an object that is getting put on the heap. and I'm holding a reference to it, a pointer that's pointing to it. Now we'll break that down more specifically when we start getting into it, but here's my cup. I make a cup object. So I'm going to call this my cup. And notice how it's using the blueprint, except color. My cup's, actually the cup on my desk is green. The size is, let's say it's medium. And the material is marble. Marb.
That's a serious cup.
This cup now has state. That's right, Brian. This is a marble cup. It is absolutely awesome.
Mm-hmm.
Now, check this out. I can take my cup and I could paint it, can't I? Maybe I don't want it green. Maybe I want to go grab some paint and I want to paint it blue. Go away. I've just changed the state of my cup. It is no longer a green cup. If I painted it blue, and then the next morning Angie walked into my office and she saw the cup on my desk, she'd be like, hey, where'd you get that blue cup from? Its state has changed. It no longer looks the same. But, surprise, it is the same object. Its state has changed. All right, cool. We come back over here to the cup factory and we make another cup. Guess whose cup this has to be? You guys are slow. Even Nina's slow.
Oh my.
Nina needs to have a cup.
I need a cup.
Nina cannot go without her coffee.
That's right.
So here's Nina's cup. And she decided she wanted hers fire engine
Okay, that's good.
red.
There we go.
Fur.
Fur.
So it's fire engine red. Its size
Large.
is extra large.
Extra large, yeah.
And what's your material?
Oh, it's gonna be glass.
Glass.
Like crystal. Crystal. It's
Crystal. Awesome. Can we all agree that Nina's cup is a different actual object than my cup? I mean, think real world. Are they two physically different cups? You know?
Well, I mean, they look different.
They're
different sizes, but they're still cups.
They are still cups, but they are two. They're two completely different cups. I was about to say, don't make me send you to the kitchen and get a darn cup. I'll do it. And I'll set two cups side by side on my desk and say, are they the same cup?
Right.
At that point, you'll say no.
They may be cups, but they're different cups.
We're going to make one more cup. And this one,
It's Andy's cup.
nope.
No.
This cup is going to be Rowdy's.
Oh.
Because he wanted a goblet.
He gets a goblet.
So this is Rowdy's cup. And its color is, he wants black.
Black like his soul. No, I was kidding.
And its size is extra, extra large. And its material is, we shall have a new material called goblet material, which forces it into the shape of a wicked-looking goblet.
Yes.
It is another cup. At this point, now remember, these objects are being allocated into memory. They're being created and stored in memory. The area in memory that they get stored is called the heap. We have three different things being stored in memory right now. Three different objects. And we do all agree that these objects are all three completely different, right?
Yes.
What makes them different? Their state.
Their states.
All of their state is different. But check this out. If I came into Nina and changed her cup to be painted blue, size it medium, and made of marble, looks just like my cup, doesn't it?
But it's still different.
Thank you. You're now an object-oriented programmer.
Woo!
Wait a minute. What did I say? That was bad. Did Jason really just say that? I don't know what I said. What did I say?
I didn't hear you say anything.
Okay. He says don't go down the rabbit hole, so I won't.
Oh, okay.
I don't catch what I said. Probably a good thing. So Nina has a cup. I have a cup. They're different cups. They have state that has been set the same. Now, you guys know I like to throw in with my baby lessons like this some technical stuff, right? Because then we feel like we're cool and we know technical stuff. So this is our stack. And then we started out in our stack with our, I'm only going to do main. So let's do, I'm just trying to decide where I want to write it. Main. Way down here in the bottom, remember last time I told you guys the way the stack winds is it winds from higher order addresses down. This area of memory down here, and then there's a little bit below it, which we talked about last time, but we'll just refer to this area right here. This was our heap. The heap is this area of memory that it's like this big pool of memory that we can use to put objects in. But we need to make sure we reclaim that memory, because if we never reclaim the memory, we'll just keep creating objects to the point that even if we're not using them no more, we run out of memory. That's bad, just in case you didn't know. So here, let's say I'm going to create my cup. So remember how these guys right here, these blueprints, what are these blueprints really? In computer terms, what are they really? If we're going to talk fancy speak now, they're types. That's good, Jonathan. But what was I referring to them as a few minutes ago?
State.
Nope. That's what's contained within.
Oh.
They are classes.
Oh, class.
That's right. So we have a cup class and we have a mouse class. Everybody agree with that? We have two classes, cup and mouse. You're going to find in Objective-C, most of the stuff that we're going to be creating when we start creating with code is going to be done through pointers. So to really create my, my cup, as Jonathan just said, cup is a type. It's a class, but it's a specific type. It defines the type cup. Okay, so I could say that I'm going to create a cup. Remember how we've gone int x? All right, I'll check this crap out. I said crap. Check this out. We're actually going to, this is real code now. I'm going to now make a cup pointer my cup. Ooh. So now, back over here on our stack, again, keeping with a very simplified stack, if we look over here, we've got x for storing something in it, and x is going to be holding a value. So let's say we end up saying x equals 5, and just pretend that x is all below. But that we have a 5 value sitting in there. But now, I'm going to go a step further. I'm going to take my cup and what I want to do I want to allocate it. I want to allocate space for my cup. The compiler is going to look at cup and it's going to say, this is how much memory we need for cup. This is what we need, memory-wise, to hold a cup. So it now knows that. And with that understanding, it is now going to, down here in the heap, it is now going to reserve a place in the heap, in memory, for a cup. And it's going to return back to my cup. What do you think it's going to return back to my cup? You're only allowed to use one word. And the answer has already been provided for you with how I've set everything up in my little bit of code example here. You guys already know the answer. You guys are now doing Objective-C. Rowdy's so awesome. Man, give yourself a high five and take a big swig from that awesome goblet of yours. It's going to return an address. Because no matter how complicated the code starts to look as I'm drawing this out or begins to look foreign, the stack is still the stack. On the stack, we still have a variable called myCup. But we said that myCup was what? Woohoo! It is a cup pointer. So important. Excuse you, Mr. Rowdy. It's a cup pointer. So you're right. Coming back into myCup, we now have a pointer that if you were to actually look at that pointer, it's pointing to the object that has been allocated in the heap. So the value, all right, you got to be real careful with the terminology you say here, Jonathan. The value is stored in the heap. Yes, if you were referring to the value as in the object itself, the object state, yes, it is being stored in the heap. And the pointer pointing to our object is now being stored in the stack. So it's like, now to go back into simple terms, we come back up here. It's like, I have created my cup.
Ta-da.
And then Angie is going to be the one responsible for knowing where my cup is at all times. So Angie is my cup pointer. I tell Angie, my cup is in the bedroom on the desk. She now knows where my cup's at. And I can get access to it through her. So again, we're getting into a situation where we're going to start dealing with stuff that you could easily make complicated, but there's no reason to. The concept here is very simple. We have a set of blueprints with instructions for how to go about building something. We can then take those blueprints and instantiate them, and we have an actual object. So we have done 3 instantiations over here. And the way that this would look, if we had coded it all out on our stack, we would have my cup, we would have Nina's cup, and we would have Rowdy's cup. And each of these guys would be pointing to their own object sitting in the heap. Pointing to that guy, and Rowdy's awesome black goblet is over here. Now you guys have all heard the term memory management at some point or another, I'm sure. So memory management. Also, most of you have probably heard the term a memory leak. Once we begin allocating objects, we're dynamically allocating memory in the heap at a size given based off the type that we need to allocate space for. And as we continue, so we all now know that this is the heap. Let me give myself some more room. If we never let go of our objects, so let's say that we end up getting rid of, or not getting rid of, the whole program ends, but we never got rid of these cups. We actually have a memory leak. And we'll be talking more and more about memory leaks a little bit this evening, and then we're going to talk more about it next week. And then in the iPhone class, development class, I'm going to be teaching you how to use some of their tools to help you analyze, basically to help you profile your code in assisting you in finding memory leaks. Life is easier now that we have the ability to use automatic reference counting because the compiler is now going to go behind and take care of all of our stuff for us. But as far as retains and releases, but you guys are going to learn how to do it manually first. So in the stack, you can overwrite data stored in it. What happens in the heap? In the heap, it's different. That memory is being held onto. It's been reserved. On the stack, we're only overwriting it because we're unwinding the stack. So the stack pointer backs back up to a higher address. And then when we call another method, or another function, we put a new stack frame on, and we just write over the stuff that's there. In the heap, when we allocate memory, that memory is now locked. It's been marked. Okay? And we'll start getting, Jonathan, into the specifics of how that works with, what was that?
It's my headset.
We'll get into how that works specifically a little bit later. I want to keep this relatively simple, or as simple as I can. All right, so now we've made a couple of cups. Same thing applies. Mouse. I can instantiate a mouse, and I can have my mouse. And with my mouse, mine is oval, so that's shape. And the color is red. And the number of buttons, I'll just put number. And the number of buttons is 23. It's a Wicket mouse for MMO stuff.
Crazy.
Yeah. And it has functionality. Connect, disconnect, and button push. And then Nina, she went out, she got a computer, and she had a mouse made for her.
Yay.
And her shape is, it's an octagon. It's a very uncomfortable mouse.
Very.
Its
But
color
it's stylish.
Its color is pink. And its number of buttons is 1. It's pretty simple mouse. Check this out. Here's a very important concept to grasp. She has her own connect, disconnect, and button press. These are what are called these methods. Now remember, functions, a piece of code that we can utilize to perform a specific task. Methods are functions, they're like functions, except they belong to a class. So you see how I've made 2 different objects here. I've instantiated the mouse class 2 times. And look at this, I now have 2 sets of this functionality. 2 sets. These are what's called instanced methods. These methods were instanced. To use these methods, I have to first create an instance of the class mouse. I have to actually instantiate it into an object. And then I can call on that guy's connect button. And it makes sense, because if I have a mouse, Nina has a mouse, and if I was to call on connect, I better have my own connect that's going to be utilized with whatever it's paired with. If it's paired with my computer, it needs to handle, Nina's mouse doesn't need to suddenly connect too. Okay? So these again are instanced methods. There are also something that's called class methods. For those of you that are familiar with like C#, this is like a static method. And I'll just mention this lightly now. We'll get into it more as we progress later. But I'm going to put a little dash out here beside the connect, disconnect, and BTM button, or button push, excuse me. And these are going to indicate instanced methods. And so let me go ahead and grab my eraser. Now I'm going to put a plus here, and I'm going to call this one, I'm an evil developer. I'm going to call this track and explode.
Oh no.
The plus is indicating that this is a class method. I do not need to instantiate this class, mouse, to use it. To call, notice how, all right, you guys are about to see what an actual invocation looks like on an object in Objective-C. And we're going to go over this more in a little bit. So I'm jumping ahead just a little bit. But you know why I'm jumping ahead? Because I know you can handle it. You all can handle this. It's going to be that easy. Because we all know that I've made my cup here. And what I'm going to do is I'm now going to show you, I'm going to make a mouse. Yeah, let's do the mouse. As a matter of fact, sorry, let me erase a little bit of this. I know the syntax will look foreign. So we're coming along. We do an int x equals, that equals 3. And then we need a mouse. So I'm going to do mouse. So that's my type. And then what kind of variable do I need? You guys all know this answer. This is an object. Where does it get stored? Where is it going to be? Where is the actual object going to be stored in memory?
It's in the heap.
That's right. Good. Awesome job. Objects are stored in the heap. But the variables, where are they stored? On the stack.
On the stack.
That's right. So that means anytime I want to point to something in the heap, what kind of variable do I need it to be?
A pointer.
A pointer. You're absolutely right. So I need a mouse pointer to, I'll call it Buzz Mouse. This is my mouse. Yay.
Yay.
And so now I can take Buzz Mouse. Notice now I'm not using a dereference operator here. So that means I'm actually looking to get an address back. Because we don't have an address right here. We haven't allocated anything. But now I'm going to come in here and be all scary fancy. I'm going to come in here and I'm going to send a message to mouse called alloc. That will cause the space to be allocated on the heap, just like you guys saw a few minutes ago when I drew the little boxes on the heap. So that's now been put there. And this message gives us back an address pointing to it. So I'm going to talk straight to that address and I'm going to call init and terminator. This is some fancy crap. Ooh, I said crap twice. All right. This class is awesome. I will break this down for you guys. I'm just trying to put it all on one line to keep it simple for me right now. What BuzzMouse has done is it has instantiated and initialized an actual mouse object. And if it's getting rough right now, that's okay. This syntax is going to be broken down very carefully. Right now, I'm planting seeds. This is rough seeds. I've got my plow running all over your brain, and it's just not pretty looking paths at the moment. But yes, this is Objective-C now. We are now moving into the world of Objective-C. Nelson was giving some of his examples in more traditional like C#. I kind of thought it would be more helpful to be what you guys are used to seeing. So in this case, Jonathan just said, if you're used to C#, it is the same as doing mouse, but it's just the same as doing just new mouse, actually. And then there being a constructor in mouse that is invisible to you. Yes, init is our constructor. Okay, so, and we're going to talk about writing our own next week. So the only thing I want you guys to understand is the following. From my little bit of weird stuff that I wrote, on my heap, in my stack frame, I now have a Buzz mouse, and it has an address, and it is, I was just hearing things. And it is pointing over here to the heap to an actual BuzzMouse object. So we now see, we hopefully at this point can start to see, oh man, thank you for showing me what pointers were earlier tonight, because I can see where that's going to be important. Because if we're now moving over to an object-oriented programming language and everything we're dealing with is objects, oh my goodness, we're going to be dealing with pointers like crazy. And the answer is yes, you are. So you've actually seen real code here for making a variable, making another variable of a type mouse pointer, and then bringing that, this is actually us instantiating the mouse pointer. So now, if I wanted to push a button, now I want to call a method on Buzz Mouse. On my mouse, I want to push a button.
Push it.
Oh boy, crazy syntax time.
Woo-woo.
Buzz Mouse space, and I'm just going to call connect. All right, so again, these are just lines of code. So first line of code, second line of code, third line of code, fourth line of code. This is, you guys are used to function calls and procedural programming that look like this. Ta-da! Look pretty familiar, right? Right? Good. It's different now. I want to call this function. It's really a method, but I want to call this functionality. I want to call this method. But we've seen that with methods now, we have instantiated methods. In my example that I've drawn here, we have two connects. We have one that belongs to my mouse, and we have one that belongs to Nina's mouse. Which one are you going to call? Stealth Coder, I'm right there with you. Stealth Coder just said, not digging that syntax. I concur. It takes some getting used to, and you will need to get used to it. I did finally adjust, but dear God, I didn't do it without screaming, kicking, and crying a little. But right now, I need to call connect, and I need to call connect on the right object. And we know that the object I'm dealing with is Buzz Mouse. That's the one I want to connect. So this right here, which we'll talk about again shortly, this is called a message. We're sending a message to BuzzNet, or BuzzMouse. BuzzNet, that's funny. What message are we sending? We are sending a connect message to the receiver, BuzzMouse. I'll break that down more when we get over talking about methods. But this is, the bottom line is, this is how we go about calling the behavior on my mouse. Because remember, what did Nelson say? State and behavior. That is what you have in a class. Okay? So I am now calling upon behavior in my thing. But now let's say that I've been tracking all the mice in the world and I want to blow them up. I can now do the following. I can do one more call. I can do a class level or a class method call. Oh. This does not require the instantiation of a class. Remember how I put a plus by this one guy right here? This blueprint came with real functionality that I can use without actually building it. So I'm going to call upon that functionality right now. Mouse. So now I'm just referring to the entire type, the mouse type. Space, track, and explode. So I just sent a message to the mouse class to call or invoke track and explode.
So anything that's a mouse.
So anything that's a mouse, if that's how I wrote the functionality in there, was to track everything that had been initialized, every object that had been allocated and instantiated. If I tracked all of those, so I knew where they're all at, and that stuff we'll learn how to do later because it's important stuff, I could then go back through and control every object. So I could go back through every single one and destroy it. So, object-oriented programming allows us to model out. Programming is nothing more than solving a problem. It could be a simple problem like calculate the Fibonacci sequence. It could be something as complex as make a student tracking system that allows a user to input grades for students and extract information from those stored grades. That's a problem. Programming is nothing more than a problem, and the program itself is the solution. As you can see, or maybe not very clearly now, but the more you work with it, the more it'll make sense. With procedural programming, it's a little more difficult to, well, it's very difficult to model out a solution that mimics the real world. With object-oriented programming, if I said that the problem that needed to be solved was the student thing that I talked about just a second ago, remember over here, these are my classes. So I would have a student class. I could have a, let's see, a course class. I could have a student. What's that?
Grade?
Well, that gets interesting and tricky. Where's grade going to go?
It's a behavior, huh?
Well, a grade wouldn't be a behavior. A grade could be a grade on a test.
True.
Or a project.
I was thinking grading. Okay. I don't know.
So we could come in here and we could say that we have tests.
Oh, okay.
And Nelson, no freaking out because I know this is extremely simplified. And then we could say that we have a repository of students. So this is, let's just say this is a database of students. So a bunch of classes. So I could instantiate this guy. And so here's my repository of students. So I'll just call it students. And then inside of students, I could hold a collection of students. So here's John, here's Mary, here's Bill. So there's John, Mary, and Bill. Now, of course, these are these guys. So we're pointing to the right object. So keep that in mind, okay? So everything's pointers when we start dealing with objects. But we have a collection of the students. I can add students. Oh, wait a minute. Add students. Where would that functionality belong? So just looking at these classes, just think about real world. If you were going to do this all on paper with somebody doing it, let's say that Angie in the other room, she is given the job of handling the database of students, the repository. And let's say that Nina is in charge of all the tests and all. So and then you've got Nelson's a student, I'm a student, Meta's a student, Rowdy's a student. So let's say that we need to add students. To the repository?
That would be Angie.
That would be Angie. And what does Angie represent in this case? And so again, we're doing real world model and we're translating that over to computer, but it simulates like real world. In that case, what was Angie? She was our repository manager. She was our repository. Right. So who would get on these classes over here? Who would get add student as the functionality?
The database of students.
The repository itself.
Yeah.
Yep. So he would have add, he would have remove. He'd have things like find. Okay. So you could then say, we've made a new student. Hey, this is Howard. He just joined the group. And then we could call on add, and we could tell add that the argument it's going to take is that student Howard, and add is then responsible for adding Howard into the repository.
Oh.
So basically now we've got the repository being added up. Later on, so that was with me calling add. So I was like doing students. And then I need to send it a message, add. And then I need to send it a parameter. And the parameter that I'm going to send it is going to be Howard. So again, here we are with another message call. First, I need to identify with this message call, what object are we talking about? What functionality are we calling? What method? What argument are we passing into it?
Howard.
Okay. So that's what we've done there. But do you see what I'm trying to demonstrate? That with object-oriented programming, we can sit back and we can analyze the problem in which we need to write a solution for in a more real-world manner. So now I can take a look at building some sort of student tracking system and just design it out with stuff that makes sense. So, I mean, my student is going to contain things like the student's name, maybe his age,
Social security numbers.
maybe a social security number. The course would contain things like maybe the course title, the level, and then the test, a test ID, and then all of the, a collection of test questions.
Oh, okay.
So we could instantiate a course and call this Math 101 up. So we've just set the title to Math 101, and we set the level to 101. And then it has a collection of, let's just say, tests. So now he has a collection of his own tests. And we might instantiate a test and fill it out to look like, the very first math test. Then we might instantiate another test and set its properties to look like a different test. And so now we can go through here and set different tests. Now we're able to say that this course has a series of actual tests that need to be done. And then we could take a student, and then we can have the student could have a collection of courses. So we now could take this Math 101 and say that John is taking Math 101. But Mary and Bob, they're not taking Math 101, so they don't need that collection. I know this is a lot to take in because I'm giving you a very high-level overview, but what I'm hoping that you understand right now, because I'm throwing around a lot of important terminology, the big thing is object orientation allows us to solve problems by mimicking real-world solutions. They also provide two other very cool things for us, and then this will wrap up the discussion of object orientation. They provide something that is called encapsulation. And you've already seen encapsulation. Encapsulation is having my own collection of private stuff. Remember when I made my cup? And then I made Nina's cup, and then I made Rowdy's cup? We encapsulated our own data. My cup it had its own color, its own size, its own material type. Rowdy had his own. We've encapsulated that data, our own data, within our own object. Now we're going to be visiting encapsulation more and more because it's going to become pretty important. But I just wanted to, that's the basics of encapsulation. The other thing I want to talk about really fast is inheritance. So inheritance is the ability, because you guys are going to see this, that's why I need to mention it. The ability for a class to inherit from another class. So let's say that I wanted to make a
Bowl.
a what?
A bowl.
A bowl? Okay, so I want to make a bowl. So I could start with a high-level abstract class called a dish. And what dish contains is only going to be color and material. So from dish, I can inherit dish. And another way to look at it is extending. I'm extending dish into another type. So it's going to take everything that's in dish, plus I'm about to add more to it. So I'm going to extend dish into cup. And then bowl. What was that, B-O-W-L?
Mm-hmm.
It's late. Now,
I hear you.
here's the fun thing about...
It's a bowl, not bowel.
Wait a minute. Is that wrong?
No, it's right. No,
Oh,
bowl,
gosh.
bowl, you know.
So here's the important thing about design, or your first look at it. I wouldn't want to do this if there's no differences. If cup and bowl only... If they only inherit color and material, why would I even do this to begin with? I could just have dish and instantiate a dish and add a type. So you'd need to have, there needs to be some sort of differentiation between these two where both of these objects are going to share the common things found up here, but then they have their own stuff that they're going to have in. Okay? Example. Let me give you a better look at this. A vehicle. And maybe a vehicle. All vehicles are going to contain engine. And
Tires?
let's say type.
Oh, type.
And type would be, let's say, wheeled or air. So I'll say ground or air. You can't instantiate vehicle. If I instantiate it, it's abstract. It's an abstract concept. But I can now come over here and I could do a ground vehicle. And let's say all ground vehicles, and the funny thing is I don't even have to do type there. Take that out. I'll just say all vehicles have an engine and a color. There we go. So now, for my ground vehicle, all ground vehicles need to have number of wheels. And what else does a ground vehicle have? That's different than a flying vehicle. Yeah, you guys are just as tired as me. All right, over here, we're going to have an air vehicle.
It's going to have wings.
Yeah, let's just say with this guy, he has maybe wing size or wing type or something like that.
Don't they have like rudders or something?
Yeah, and maybe rudders and other stuff. But here's the thing to understand. If I create a ground vehicle, I could set how many wheels it had. So ground vehicle, pointer, my car. Or I could say an air vehicle, pointer to my plane. And then both of these two objects here, because now remember, they get built out on the heap, so they're instantiated to actual objects once I allocate them. Now with these guys, no, man, I see that that the wheels thing, you guys are trying to give wheels to vehicles. This is the future. These guys hover wheels. Man, these are hovercrafts. So nice try, though. So now I could come in here. And I could say that, you know, this guy right here has a color and an engine, but he's my car. And this plane, my plane, has a color and an engine, but he has 4 wings because he's awesome. And my car has 36 tires because it's like a centipede car. No, it's one of those stretch limos that go on for like ever. And I like come rolling up and they're like, hey, it's McBuzz. All right. Yeah, let's go party. Check this out. Now, let's say that my ground vehicle had wheels and I wanted an aircraft to have wheels too. I could have done this. Instead of air vehicle inheriting from vehicle, I could have inherited from ground vehicle.
Because it automatically would inherit.
Yep, so now I put on wings. And now if I instantiate an air vehicle, it has wings, wheels,
and an engine.
And an engine and color. Otherwise, if I instantiate just a ground vehicle, I only have wheels, engine, and a color. So that is inheritance. And that is very important because we will see it here in a few minutes once we start talking about object orientation. So with that, unless there are any questions, that is going to conclude part 2. And I know we need to go on break because it has actually been an hour and 45 minutes of pure lecture this time around. Kind of awesomeness. I heard that in Objective-C, you can't extend from a class that has already extended. Well, we've got all sorts of fun stuff to talk about, Mandrill. One thing at a time. Only 3 parts tonight, Dementis. You can hang up and watch the recording later. I don't want anyone to suffer. We've only lost 3 people since the very, very beginning of tonight's class, which is awesome. But when we come back, we're going to be cranking up the amplitude a little bit because we're going to start looking at Objective-C. And we're now going to get into what is going to be a new language. But don't forget this. Objective-C is just an extension of C. Okay? So everything we've done in C, we still have. But now we have object orientation built in that we can take advantage of. And we're going to look at all of that stuff. So that wraps up part 2. You guys all take a 10-minute break, stretch your legs. You guys have all been epic. Thank you. And I'll stand up for a minute myself. And then we will continue with yet more awesomeness. That's right. It's awesome. I've got passion. Hello, everyone, and welcome back. So, continuing on, during the break, we came up with some of the most amazing analogies ever to help solidify the class example and object example. Unfortunately, we can't talk about them because they're not appropriate. So, moving on. It is now time for us to get into part 3, which means, I guess I could have already done this a second ago. Let's go ahead and jump over into a new...
Brian says what happens in 3D Buzz Break stays in 3D Buzz Break.
Yeah, no kidding. So let's go ahead and create ourselves a new layer.
Let's do this.
I'm just a tad bit tired, so please bear with me, guys. From like I said, I'm going on almost no sleep.
And he didn't even have those pink fuzz.
No, didn't have any pink fuzzies today.
No.
Okay, so part 3. What we're going to be looking at is we're going to be moving into Objective-C. And as we know, Objective-C builds on to C. That's the most important thing to understand. And we're going to kick things off by just jumping right on over into Xcode. And let's go ahead and create a very basic Objective-C program. So File, New, and if everybody wants to follow along for this very, very first part, let's all make a new program together. So File, New Project. So we're going to make a new project. We're going to make another command line tool. So make sure you're looking at command line tool. Hit next. And let's call this basic Obj-C. Yeah, basic Obj-C program. Nah, that's good enough. Forget it. All right. Call it whatever you want, dang it. This type drop down, if you guys recall back at the very beginning of this course, I had you guys making a C program. Well, the type of program we're going to make now is a foundation program. Creating a foundation program, this is going to tell, it's going to be using our foundation framework, and this is going to tell our compiler and Xcode. It's going to tell everybody that, hey, we are using Objective-C. So make sure you have it on foundation. Make sure to turn off use automatic reference counting. You guys want to learn memory management for real? Then we can talk about reference counting, automatic reference counting a little bit later. So with this all set up, let's go ahead and hit next. Next is going to be where do you want to put it? I've just got my programming folder in my documents. I'll just put it there. Make sure that you do not have create local get repository checked. We don't want that. And we don't want to add to any project or workspace. So with all that set, go ahead and hit create. Now, the first thing I'd like to point out, see, we still get that horribly scary looking screen that we saw way back at the beginning. But let's come over here to the side and let's click on main. The very first thing I want you to notice is that main is now main.m. So it's no longer a .c file. So let's have some fun.
Let's do this.
First thing we're going to do is delete everything that's inside here. Delete it. You should be done by now. So that we can see this thing being built up and we can understand the basics of it. I'm going to start by an import. Huh? An import? A little bit different than what we had back in the C program, isn't it? What did we have back in C? What did we use before?
Oh, that was
include.
Include, yeah.
That's right. Import.
STDIO.
Import is also, import's just like include, except, and we did not get into this before, you can run into cyclic include conditions that can be a nightmare when working with header files in C programs. Import, that directive is like a smart include. It will make sure that you do not have a cyclic inclusion of these header files, which is really cool. So this is the first cool new thing that's part of Objective-C that we get to use, because Apple was like, man, include, that's lousy. Let's do import. Now, the header file, this isn't located just in system like we were seeing with standard I/O, and also we need to tell it that it's going to be found in foundation / foundation.h.
Oh.
And notice I've got my less than and greater than symbols around it, which are indicating that it's not a header file that is in my local folder. This guy right here is in my system folder. And then to drill down further, it's in foundation, and it's the foundation header. It's a header file for lots and lots of classes. Lots of cool stuff. Okay, so now that we have imported our foundation.h, our header file, the next thing I'm going to do is I'm going to do an int main. Man, that should look pretty darn familiar. Most basic Objective-C app out there. Now let's do something inside here. I'm going to do a compiler directive. For Objective-C, it's done with an @ symbol. So notice, of course, I'm tabbed over. You should be automatically with using the auto-completion from Xcode. I'm going to do an @ symbol. Start typing out auto release, and you'll see auto release pull. So with it partially typed out, you can hit enter or you can hit tab. If you hit tab, it's just going to jump you right on down to the statements that now go inside of the auto release pool. So far, should be nice and easy. I'm going to hit the delete key to get rid of that statements, only because I want you guys to go up to the auto release pool and drop that line down, because that is the convention that I always use, and it's much better as far as readability goes. Now, an auto release pool is very cool. This sets up a special pool that objects are put in. An auto release is really a bad name for it, in my opinion. It should have been, in my opinion, it should be called a delayed release pool. But what this guy does is he will simply issue all objects that are stored in this pool. It will issue a release command when this pool is no longer being used at a time it deems appropriate. So this deals with memory management. At the moment, that's all I want you to know. We will come back to it tonight. Ladies and gentlemen, I told you tonight would be an action-packed night. So now, what I want you guys to do is tab in, just one tab. Mine went over twice because of the formatting that was there. Just hit your backspace key. And we're going to make our first type. We're going to use an NSString object. So it's a capital N, capital S, and you'll see that with highlighting, or the auto-completion, we're on NSString, so I can just go ahead and hit tab or enter. And now, so I'm just making a variable. You guys remember int x? I'm doing the same thing, except for now I'm making a variable that's going to hold a reference to an NSString object. The object will be of type NSString. So we're going to be creating an object. So what kind of variable does this need to be? I've been drilling you guys on this all night long. Even though you may know nothing about it. Go ahead.
A pointer?
A pointer. That's right. NSString needs to point to the object that gets created on the heap. And now I just need to give it an identifier. Yeah, even Mando's like, man, Nina getting this stuff. She is. So what I'm going to do is I'm going to give this, I'm just going to call it MSG. You could call it hamburger for all I care. Remember, this is just the identifier. It's just your name. Equals. So far, so good, right? We've done nothing more than declare a variable with a type. Now I am going to initialize it. So, and yeah, try to avoid message is completely fine.
I think he means the spice MSG or whatever it is they put in food.
No, I bet he's actually talking about. No, he is talking about Chinese. You got me.
He got you.
Yep, you sure did. Because believe it or not, some people hate. I've heard people in the past that hate the word message and hate MSG. Yeah. So, anyways, continuing on. Very, very good job, Mr. Stealth Coder. You got me there. So
words there.
No, don't apologize. That was funny. So what I'm going to do is I'm going to initialize this guy. Now, remember when we said int x equals 5, right? What I'm going to do now, so that was a declaration of initialization. I've done a declaration here. I'm going to initialize. I'm going to initialize this guy with a literal, just like when you say int x equals 5. The literal value 5 was put into x. So I'm going to put a literal string in here, but it's a very special kind of string. What kind of string? This is a great trick question. Well, it's not even a trick question. What kind of string do I want to create? I'll give you a hint. Look at my type. What kind of string do I want to create?
NS?
You got it. An NS string. So to create a constant NS string, I do the following. I do an @ symbol, and then, well, look at that. It's already popped out and is ready to help me out. So I can just simply go ahead and hit tab to jump over into the string and start typing out hello. And since Exion left, we no longer have to say hello nothing. We'll say hello world. So I have now put that in, and I'm going to terminate. There is our very first statement. All we've done is created a variable that's holding hello world. But we are all smart. We all know that what we're doing is a little more complicated than just making a variable that's holding hello world. We are actually creating a pointer on our stack called MSG that is pointing to an NSString object that has been instantiated on the heap. And the text in that object is hello world. How do we know that? This @ symbol right here, before, if I was to take this @ symbol out and give it a second, you can see we get this nice little pop-up here. And we see incompatible pointer types, initializing an NSstring with an expression for basically a char array, okay, using 14 bytes. So we don't want to use a char array. We want an actual arrays. When are we going to be covering arrays was asked. I will find some way to start getting collections in. It wasn't, we could not have put it in with the 4-week program that we have now. We'll find some way in the iPhone class or workshop or somewhere to get that to you guys. Because as you know, with arrays and then with pointers, that turns into an entire night lecture right there. Okay, so this with taking out the ampersand, what we've done, or I'm sorry, the @ symbol, what we've done is we have tried to put just a regular char array, just an array of chars, into an NSstring type. We can't do that. In an array of chars, Stealth Coder, that's a very good point. All arrays of chars, when treated like a string, all have a terminating null at the end. So it has one character that you can't see. So in this case, wrong type. But we can fix it by coming in here. Oh, and you notice, by the way, only because I thought this was cool, fix it. Insert the @ symbol. How do you like that?
Huh.
Click on that. I just double-clicked on it and put the @ symbol in for me. Now let's talk about what that @ symbol is doing. Remember these @ symbols? We're in the world of Objective-C now. These @ symbols are directives for the compiler. This is telling the compiler, since the compiler sees that we've got double quotes following it with a string, it's telling the compiler that we are going to create what is called a constant NSstring object. So this is a constant NSstring object. We can actually call methods on just this guy right here. And we'll probably play with that here in just shortly. So this is what actually creates this NSstring object that's sitting out there, and the address of that object gets passed back to MSG.
Why is my little thing
And
yelling at me?
let me take a look at Nina's. NSstring equals at hello world terminator and unused. Read what does your thing say? What's your warning at the moment?
Unused variable.
Unused. We haven't used it.
Oh, okay, so it's okay then.
Yeah, it's okay at the
All right.
moment. So what I want to do now let's stay kind of focused, because we can quickly start running down a rabbit hole into a lot of different directions real fast with questions. At the moment, let's keep this focused. It's going to be critical, or we're not going to be able to get through everything. So just know we've created it. This is how we allocated and created an NSstring object. Since we put this compiler directive in front of it, the compiler took a look at that and it handled the allocation and initialization and setting it for us, and then it returned our address back to here, so we're now pointing to it. Something to note, that NS strings are not mutable. So if I was to turn around and say MSG equals and point it to another object, this object still exists. And we'll get into mutable strings a little bit later. Okay, so now let us go ahead and use this. So what I'm going to use is NSLog. And NSLog is a function that is available for us thanks to Foundation. We'll talk more about it in just a moment. And Mandrill said, so the @ symbol is just a convention for Objective-C, right? And that is correct. It is for Objective-C as a compiler directive. So it's a way for when dealing with the Objective-C language to give instructions, again, dealing with the Objective-C language for the compiler. In this case, what we told the compiler to do was to make an NSstring constant that had hello world initialized. Now, NSLog is available to us because we're using Foundation. So we're going to use it. And what I mean, right here, I could just say hello or hello world, but I like the idea of using an actual variable in our very first program so that you guys could start seeing where this is all going. So what I'm going to do, and this, follow me slowly, I'm going to put an @ symbol. I'm going to hit enter to jump inside of my string, so inside of my double quotes. And I'm going to say MSG contains colon, so this is just string text, right? Now I'm going to use one of those formatters. But I'm going to use a very special formatter because we're talking to Objective-C here. I'm going to use % and the @ symbol. We're going to be covering this more later, but this is letting us basically, this formatter is saying print an object. Okay, print an object. That's the formatter, print an object. And then with objects, you get to control how things print, but objects already have a default way that they're going to print. Like an NSstring knows that if you go to print that object, what it's going to do is just print what the text is that's being stored in it. Again, we'll spend more time on that later. This is just the format specifier for printing out what is in our NSstring. Let's leave it simple like that. So we're going to say this. So right now, if I just stopped right here and jumped out here to the end and said comma, and then let's go ahead and just send message to it, and then tab over for terminator. If we just do that right there, and then let's go ahead and up underneath the auto release pool, up underneath that closing parentheses for him, let's do a return 0 and terminator. Yeah, we're gonna find the @ symbol used for a few different things. We're gonna see it a lot. So let us go ahead and Command R to build and run your program. Now we're not using printf. Instead of using printf, we're now using NSLog. So most places you use strings, we're going to be using that @ symbol a lot. It all depends because NS strings come with a lot of different stuff. Now Jonathan asks, can I use printf? Yes, I can. Because this is so important to understand. What is Objective-C? It is an extended version of C. Agreed? Agreed. So how would we go about using it? Where does printf reside, first of all? Where does printf reside? In the standard I/O. So we need to make sure that that gets included somewhere. But we don't have to do include. We can use this fancy import. And then same exact thing. This is system header, standard IO.h. Whoops, I did not mean to do that. So far, so good? Okay, now, I might break your head here. And if I do, I apologize, but this is just from my good buddy Jonathan who asked. Let's say that we wanted to use printf now. Watch this. Oh my goodness, there's printf.
Ta-da.
But printf is looking for it's looking for a character array, and which is going to be a sequence of characters in a string. But what we want to do here is a little different. I mean, we want to do that, but watch this. We're going to use our standard old double quotes, but we're going to say that we're going to use a format specifier, %s, which you could use in regular C programming as well. We're now, this is where you gotta really kind of think about it. We can't use the @ symbol. We're now using printf, which has it has its own format specifiers. And %s is a string of characters. It's a sequence of characters, a string. So we need to put that out. So now I need to remember, after we use a format specifier, we need to then hand an actual thing over to it. Well, what do we need to hand over to it? Well, I can't put an NSString object over there. I need to hand my MSG to it, but I can't just do MSG. Let's tab to the end and terminate that.
The ampersand?
And we've got a problem. I'm not even going to put my thing over that. Well, the ampersand is the address of. But it's the address of what? An object. See, before, this is such a great distinction that you guys are now going to have to start understanding. When we went over pointers earlier tonight, we were pointing to value types. Value types exist on the stack. So they're already values. Now we want to point to an object. So we need to talk to this object through the pointer and utilize special functionality that's already there for it to convert the text into a sequence of characters for us. See, it's really much more complicated than it looks, because you're thinking, oh man, MSG just contains the string hello world. How hard could it be? Well, hello world is actually sitting in an object that has a crap load of state and behavior stuff. And one of its states just happens to be the text. So here's what I'm going to do. I'm going to say that MSG, but I need to call a function on it. Now it's time for us to start talking Objective-C, not C. Now it is time to send a message to the message pointer. That's right, Mandrill. Mandrill's all over this. It's time for brackets. So I'm going to send a message to message, and the message that I'm going to send, so remember, this is like a function call. This is a method call on MSG, which is the object in the heap that contains hello world. So I'm going to use C string, and how nice is that? It's already on the method that I want to call. I'm going to use C string using encoding. I do not want us to get into encoding right now, because that would just wreck the entire class. In the old days, you could just use C string. But as of OS X 10.4, it's been depreciated. So you can't use that anymore. Oh, well, yeah, you don't want to use that. You're going to get a warning. This is the proper way to go about the conversion. So what I'm telling what I'm telling message to do is to run this function. Notice that method. I'm going to start saying methods now. So we're going to run the C string using encoding method, and it's expecting an argument. So it's expecting information. It's expecting us to tell it what kind of encoding do we want to run. And I'm sure most of you guys have all heard of UTF-8 encoding. It's kind of been standardized forever. You know, we had ASCII, and then we had UTF-8, where we expanded our set. I'm just going to simply do UTF-8 encoding. So this is going to be N, S, U, up, there we go. So again, I'm just trying to point out, make use of, because the stuff is going to get verbose, and it's going to get verbose fast. Start making use of autocomplete. So I'm going to make use of our NS UTF-8 string encoding, and then I'm going to end my message call. Now let's take a look down here in our output. Notice that NSLog, on everybody's computer that followed along with me, like good guys that you guys are, Everybody did this. And when you ran your program with NSLog, NSLog is much more, once again, verbose than printf is. Printf just prints whatever the heck you tell it to print. NSLog is going to print out the date, the time, and it's also going to print out our project. It's a bunch of different stuff it's going to print out. And then finally, it's going to get down to the actual string that we told it to print. I mean, NSLog, come on, guys. The idea is logging, so we want to log information. So now I've commented this out. So remember all these two lines down here that we had before. If I run it again, look what we get now. There you go, Mr. Jonathan. I hope that answers your question, sir. And you guys are very welcome. So, again, C string, older, it's been depreciated. No longer using that. Now we can do C string using encoding, and we can encode depending on what it is that we are using it for. So let's go ahead and take a look at what we've got here. As far as our anatomy of a basic program goes, so just the things I want to point out. Import, we've already talked about. This is like include, but you can think of it as kind of like super include. It makes sure that it doesn't do a cyclic include or create a cyclic include problem. We also saw that we can use import on our regular C standard library as well. We've got main like normal. We've set up an auto release pool. And that will become much more, that'll become explained a little bit later. Then inside, because we're using Foundation, we took we made use of the NSstring type by creating an NSstring pointer that points to a constant NSstring that we defined right here. Hello world. Then we saw NSLog as a function. And that is a function available to us inside of Foundation. As a matter of fact, inside of Foundation includes a ton of headers. And one of the headers that's found inside of function is called the NSObject runtime. And it's inside the Objective-C runtime that we find our NSLog defined, or prototyped. So that is what's going to give us our logging out, our printing out to the console. But then we also saw that I was able to come in here and create my own utilize printf, call methods, from standard C library. And we saw that we could mix this along with Objective-C stuff by sending a message. So I'm just going to do a regular printf. I'm using a format specifier of %s, saying that I want to format what's coming in as a string. And then I do a message call to the object message. So now I'm looking over into the heap. I'm looking at the actual object. And on that object, remember how I showed you guys the behavior that's sitting there? So now I'm pointing to that behavior. And I'm calling on the C string using encoding method, and that expects an argument, and that is the argument that I am sending in. That's the program. A very basic Objective-C program. Now, you guys like to have fun. I like to have fun. I know it's late. I know some of you guys are tired, but let's have fun. Let's make it a little bit more interesting. Let's go back to NSLog. The printf we can come back to later. What if I wanted to say message contains whatever's inside a message, comma, and the length of it is, and I wanted to say how many characters it is. How do you think I would go about this information? Real quick, just looking over at BuzzNet, Stealth Coder says, what is the 4872? I would need to look that up. I honestly don't know. And Mandrill and Dementis team together and are absolutely right. We're going to need to send a message to MSG, and Dementis put dot length, but we're not going to talk to dot length. We're just going to send a message to length. So I will simply come in here. Well, first of all, what do we know we need to do? We need to go in here and format it. And the format specifier is going to be, I believe it's long unsigned that we're going to need. So now I'm using another format specifier, so I need to come over here with another comma, and we know that I'm going to be messaging MSG. So I'm going to go ahead and put my square brackets, open and close, come inside, and do MSG, space, length. And so, yeah, it was. So if I was to take this, %LU, and try to put my D in there, we should get a warning. There we go. And we come over here, and, oh, an LD, my bad. So an NSU integer. So it is an unsigned long. So I was right there, but LD will work. So will the other one. But anyways, you can just double click to put the %LD in there. And now, as long as, we got to be real careful with this. If I wanted to come into MSG dot and do length, this is something that's very important to understand. Next week, we're going to begin talking about properties. The interesting thing here, a lot of you guys are like, whew, okay, this looks like something that, is more familiar to me. This is nothing more than syntactical sugar for expressing what we had a second ago. The compiler actually changes, you get it changed into that message call right there, is how Apple will describe it to you. And Apple's exact words is it is syntactical sugar, making it something a little bit more familiar to those of you coming from other dot operator languages. And correct, Mandrill, it is LD, not ID. That's an L for a long number. So now if we go ahead and run this guy, we get hello world, and the length of it is 13. And so now we see that 13. And Dementis says, I like the dot, so I'm going to keep the dot. Get used to using messages, or you're going to find yourself getting burned with the dot often. Because we're not going to be synthesizing any properties tonight. We'll get into property synthesization next week. All right, very, very simple program. And now we've sent some messages off. We've talked to some objects. Man almighty. How cool is that? Man, watch this. I want to prove to you. Remember how I said that this line right here with this @ symbol, this is a constant NS string? Watch this. I want to show you guys sending a message to a constant NS string. So I'm going to say I want to know how many characters are in Jason Busby. Yeah, that sounds good. So let me change my text around to say, and Jason Busby is blank characters long. Just say is blank characters. There we go. Keep it all in one. So this is string literal. But to be more specific, it is an NS string constant that is created. So what I'm going to do is run this now. Build succeeded, and Jason Busby contains 11 characters. I just wanted to point out that even though it's a literal, it's still, the compiler knows this is going to get turned into an object, and it has a location. And because it is actually an object, I can call a method on it. And that is really freaking cool. Piece of cake, guys?
Woo-hoo.
Yeah!
Piece of pie.
And why does NSLog not use that notation? Because NSLog, again, it's just a regular C-style function. Remember, I can mix C functions as long as I declare them through prototypes or include header files to files that define them. I can use regular functions all day long. And NSLog was something that I guess they felt didn't need to belong to an actual class. So it's just a function. That is why I really wanted to spend the first 2 weeks of this course giving a crash course into C. Because everything we've done in C can still be used right here, plus a whole lot more. Okay, so basic anatomy out of the way. We've played with a few things. Now what I'd like for us to do is to spend just a moment. Are you okay, Nina? Am I killing you?
No, I'm fine.
Okay.
That was my inner 12-year-old.
Oh, okay. So let's go ahead and... is Nelson still even there?
Yeah, he's there. I see him.
Is he actually listening?
Mm-hmm.
Yeah,
Okay.
I'm here.
So what I want to do now is jump over to...
For a second, I thought you were going to want to talk.
Oh, I could just turn it over and let you do the next program. Now, what I want to do is turn over here and talk about, for just a minute, the foundation framework. Whoa, just kidding. Okay, so the foundation framework. Man, this dude is so important. We saw the C standard library made life easy for us, did it not? With the C standard library, we could make use of, we only really worked with just a couple of header files, but we saw that, you know, we could already have the std bool, so we could have true and false defined for us. We saw that with standard input output, that we could go in there and, we could go in there and we could take advantage of console input and output. You know, all this stuff that was predefined for us. So we have all these tools right there at our fingertips. Well, same thing goes with Foundation Framework. The Foundation Framework defines, it's a base layer of Objective-C classes, first of all. Well, we are going to gain access to all sorts of cool stuff available to us in the Foundation framework. The most important thing to understand is that all of our Objective-C objects, remember how we talked about inheritance? All of these objects, including the ones we're going to make tonight, are going to inherit from NSObject. And NSObject contains a few things inside of it that are very, very important to us. Tonight we'll take a quick look at retain and release that is in NSObject. Those two guys are used, those two methods, when sent messages to, are used for controlling a reference count for an object. When an object hits a reference count of 0, the system deallocates it. So we are responsible when we start passing the reference around, we're responsible for grabbing ownership of the object and then releasing ownership when we're done with it. If somebody claims ownership then forgets to release ownership, will actually cause a memory leak because its reference count would never go back to 0. But all of that cool reference counting mechanic that I'm describing is part of NSObject. So as long as every object inherits from NSObject, so as long as NSObject is the very base object or the superclass, then we know we have that stuff. Somebody say hi in BuzzNet. I want to make sure BuzzNet isn't dead. I just haven't seen anybody say anything over there in a while, and I'm afraid that it might be okay. Nobody has said anything, so let me refresh real quick. Apologies, but I've been trying to keep eyes on BuzzNet and the question panel. So I'm logging back in. And as soon as I remember my password. And jumping back into the class. And okay, there we go. All right, thanks guys. Yeah, mine had stopped working, so anything that had been said, I did not see. Since Jonathan said earlier about whatever it was he said something about. I don't remember now.
Some stuff and things.
Some stuff and things. Okay, so back to the framework. So the framework, when designed, it had a series of goals. The goals for the framework was, one, to provide a small set of basic utilities, or utility classes. And we will be making use of many of these guys. We've already made use of, well, NSLog is, he's in one of the header files, but he's a utility that is available to us. Let's see, what else? We've got software, the software, and this I actually got from Apple's site that I wanted to read off to you guys. Make software development easier by introducing consistent conventions for things such as deallocation. I won't jot that one down. We'll be talking about deallocation shortly. But across the entire framework, the way things get deallocated are all the same. So support for Unicode strings, object persistence, and object distribution. Provide a level of OS independence to enhance portability. So those are some of the goals. So as far as I'm concerned, those are all groovy, but the one that's of importance to us in this class is the basic utility classes, along with a ton of other classes. It is also going to provide for us the root object class, in which all classes derive from, and this is NSObject. We're going to see this. We're actually going to use it in a minute. Okay. All right. It also is going to give us classes. Again, inside the Foundation framework, we're going to get classes representing classes are going to represent basic data types. And we've already been working with strings, so we know that it provides NSstring for us, but things like strings, numerical values, arrays, etc. That one's going to be very important to us, and we'll be looking at a lot of these as we progress through next week, and then especially in the iPhone class, we're going to be looking at a lot of different types that we will need for application development, for real application development. Let me say classes, me and my horrible spelling, sorry. It also provides collection classes. Remember when I was drawing over on the whiteboard and I showed you a student repository? And I said the student repository held a collection of these students. So the Foundation provides us the ability to use dictionaries, etc. So collection classes is what that's generally referred to as. And then we have classes for for things like that represent, let me just say, represent system information. An example would be a date. So we have an NSDate object that we can use. And the list goes on and on. But these are the most important things to us. By using the foundation framework, they say don't reinvent the wheel. We've got so many different kinds of wheels invented and at our disposal. It's crazy. Now, the class hierarchy in Objective-C, in the foundation framework, starts at the top level. I'm not going to go through all these. I'm just going to show just a few of the major categories, and then I'll just mention the other ones. But we already know NSObject. This is the highest level. This is our root object, our base. So now, from this, we have different types of objects. I'm not going to specify classes. I'm just going to say different types. And the types break down into different categories. And I'm only going to put down the important ones. We have value. So value objects. An example, NSValue, NSNull, etc. And things like NSValue can be drilled down even further into other classes representing specific types of values. So we'll be working with value objects. Another category that we're going to be working with is going to be strings, which we've already done. With strings, we know that we're going to be working with NSstring. As I almost forgot, Nina just pointed at the screen. I'll look up in just a second, guys. I take it there's a question. NSstring, NSFormatter, etc. We also have NSstring that we can derive from mutable strings. NS, does it mean something? If I recall, this all derives from where it had originally come from was next step. And that's where NS comes from. You remember Next Step, Nelson?
Yeah, that company from forever ago that Steve Jobs worked at.
It was forever ago, wasn't it? But that is, I read that at some point, long time ago. But that's where it comes from. Okay, so strings, and then one more, collections. Now, keep in mind, these are going to be clusters of classes. In collections, we're going to have things like NSArray, NSDictionary, etc. So class is all about collections. Okay, so you're going to be able to identify classes that belong to Foundation really fast because they're all going to be prefixed with NS for the type. Now, I'm just going to name off other things just to I'm not going to write all this down, but just to give you an idea of the flexibility that you have at your fingertips by using Foundation. You also have, and again, these are clusters of classes. You have classes for handling XML, so you can do XML parsing and all. Predicates, so you can do expressions and all. Operating system services, file system, URL, inter-process communications, locking and threading, notifications, archiving and serialization, Obj-C language services, scripting, and distributed objects. I just looked up, saw the question about JSON. They don't have a category for JSON. And if it's not built, I've never looked for it because I've never needed it. Oh, hey, how you guys doing? But I guarantee you that if it's not included in framework, then it's going to be it's going to be an API that you could easily grab and use. I guarantee you. There are so many awesome APIs out there that you can use with Objective-C. And I know that just from all of the iPhone development stuff that I was doing a couple years back. Man, there's some good stuff out there. Some really good open source stuff. So anyways, that's just a quick look through the Foundation framework. Yeah, I don't think that it's in framework, but they included it in iOS 5. Well, if so, then that's awesome. But anyways, this is just an overview current from Apple of what they've got for the Foundation framework. So now we know we have all of this at our fingertips. What I want to do at this point is to switch gears, and we can all follow along with me. I was going to do this a little differently. I was going to do it twice, once explaining through it, then once having you guys follow it. But I know we're really pushing the class tonight. This will probably end up being our longest class to date for Objective-C. So I want you guys to follow along. We're going to write another program from scratch. And this program is going to be it's an object-oriented hello world. And what we're going to do is we're going to create an object I'm calling it the message dispatcher. And the reason I like the idea of getting this into class tonight is so that you guys get to see kind of everything being all put together in creating an Objective-C object-oriented program. I totally dig that idea. So, what I want for you guys to do, let us jump in here into Xcode, and I'm going to do a new program, and let's call this a new project. So again, follow along. It will help you stay awake. Follow along. We're still holding on to everybody. You guys are epic. We're going to do another command line tool. Next, following. Good. Now what we're going to do, project name, OOP, hello world. I don't know. Sounds good to me. Make sure the type is set to foundation. OOP. That's right, Jonathan. You're getting tired too. Type, make sure it's set to foundation, and we're not going to do any automatic reference counting. So now let's go ahead and hit next. Where do we want to store it? Again, I'm just going to store it in my basic program area, and no local Git repository needs to be created. And I don't want to add this to any other project or workspace. So let's go ahead and create it. We've got main over here. So for main, let's kill it. All right. It's more fun when we do it that way, in my opinion. So, and go ahead and hit Command S so we can save. Notice we have no errors. That's pretty groovy. All right. The first thing we're going to do is we're going to create our header file. I want to jump back over for 1 second into here. And how much room do I got? I'm still good on room. I gave you the talk earlier about classes and then the ability to instantiate classes. We're going to be creating a class called Message Dispatcher. So this is going to be our class. When creating a class, well, first of all, let's just look at what will be in, just so that we stick with what we've seen so far. Inside of it, we're going to have one data member, one instanced variable. They're called IVARs. You're going to see IVARs quite a bit when you start looking through like iPhone books and Objective-C books. We're going to create one instance variable in here that is going to be of NSstring, and it is going to be a pointer to our message. Remember, classes, state and behavior. That will be used for our state. The behavior that is going to be available for us are going to be 3 different methods. First method is going to be just message. So let me see, how do I want to write this out? So I'm just going to say, let me just put it, I'm just going to keep it easy. Message. I'm not putting in the signature. The next one is going to be set message. And then the final one is going to be dispatch message. And what I'm going to do is spend more time talking about this next week, because in my head I'm actually adjusting what I'm going to teach tonight. I've already gone beyond what we were going to do for tonight's class. And I'm going to push it further here. But then I'm going to break some of the lower level stuff down into next week's class, just so that I don't end up, because I'm going to be very verbose going through this, guys. Sorry. I want my beginners that have stuck with me all night long through 12 billion hours, or at least it feels that way. I want you guys to, I got fish guts on my face. Jonathan just smacked me with a fish. I want you guys to try to get as clear of an understanding what's going on, and then we'll start breaking down from there. All right, so these messages, these are methods, okay? So remember, state and behavior. So these guys are our methods, and they're going to be taking in arguments. The behavior of this guy is going to be to set, to retrieve what's in message. This guy's job is going to be set message. And this guy here is going to be, we'll do printf. So I'll just say print message. Okay, so this is what we are looking to put together. So far, so good, hopefully. I'm very loosely just giving names only for the methods. Now, when creating a class or defining a class, that's horrible. In Objective-C, we need two things. We need an interface and we need an implementation. Okay? So we need an interface and we need an implementation. The interface is what we're going to use for declaring our instanced variables, so our IVARs, and also declaring or prototyping our methods. So this is the interface. This will be a .h file. This will be our header file. There is no reason, Jonathan, for me to cover non-atomic tonight because we're not synthesizing properties yet. Yes, we will be covering that next week. Atomic and non-atomic. Okay, so, which won't really be affecting us whatsoever with what we're doing. All right, so, but I will talk about what they are. The implementation file is going to, first of all, be a .m file. Get it? Implementation. Okay, Jonathan, I got to sound more awake. All right, so .m is going to be our implementation file. What does that mean? That means we need to implement our actual methods. So this is where we define methods.
Yay!
That's it. It's that simple. So we know when we are creating a class in Objective-C, we need an interface and we need an implementation section. Yes, we could put this in a single file. We will not do that. That is very bad form.
Bad, bad, bad.
Our interface will always exist in our header file, and our implementation will always be in the M file. How we feel? So far, so good. Does this make sense? I'm trying to go slow. Trying to treat you guys all romantic and just take it easy. Good. Siba says it's cool. I'm glad it's cool because I'm trying to be easy for you guys.
Yeah.
Easy classing by the buzz. All right. So that's horrible. Oh no, Stealth Coder's got to go right when it gets awesome. No. Okay. I understand, man. It's so late. You have an awesome night. All right. So continuing on with the gloriness that Stealth Coder is about to miss, what we're going to do is jump over and actually use it. So we've drawn this guy out. So let's take a look at building an actual message dispatcher class. So I'm going to jump back over into Xcode. And I'm just going to come up here to my folder for the OOP Hello World. We're just going to keep it real simple right now.
Okay.
Oh, Stealth Coder had to go when I was getting romantic.
Oh.
I think he was getting a little nervous. Do you not want a hug from me, Mr. Stealth Coder?
Oh.
Okay, so everybody, follow along.
All right.
Over OOP Hello World, right-click.
Writing, clicking.
And go down to a new file.
New file.
And the file that I want you guys to create, come down to Other. Under OSX. Go, yes, there is a template for doing this. I want this very first pass. I want everything to be manual. So please, come down to Other and select Empty. What we're going to do is create just an empty file. And then click Next. And it asks, where do we want to save this file and what do we want to call it? Now, the naming convention here for classes will begin with a capitalized letter. What is our class name? Message Dispatcher. That is also the name of our files. Notice capital M, E-S-S-A-G-E, capital D, I-S-P-A-T-C-H-E-R .h.
H.
Put that .h in. Where do I want to put it? It's already where it needs to be. In the group, virtual folder, OOP Hello World, in that group, hit create. Dude, you have an empty file.
Dude.
How awesome is that?
Woohoo.
So everybody, because I know that all of you guys that are still with me are following, let's do something with this header file. Let's look awesome. The first thing we're going to do with our header file is, you know how we bring in foundation, that header file, and how we might want to bring in stdio. Remember that guy? We import these in our header file, and then over in our implementation file, we'll only do an import of this header file. So everything gets chained together and it gets included or imported properly. So it keeps our implementation file nice and clean. So here in the header file, let's do what we've all done now. Let's go ahead and do a pound import and then do an open. And we're not using templates and all, so we're going to have to fill a couple things in ourselves at first here. So we're going to use a less than symbol and type out foundation with a capital F / foundation.h. And then a greater than symbol. And then since I know we want to use printf, just for our good friend Jonathan, let's go ahead and do a pound import. And let's go ahead and bring in our stdio.h.
Yay.
You got it, Seabite. All right. Everybody knows how to do this. So far, it's good. Now, this is where stuff's going to get funky. You guys ready to get funky with me? Let's get funky. We need to use a compiler directive. There you go, Stealth Coder. He's in the spirit now. Yo, man, this is how it's going to go. We're going to tell the compiler. Notice how I'm talking to the compiler now. And look at this. Suddenly, it's smart enough to know kind of what's going on. It's like an implementation, and we can do this. No, we want an interface. So start typing out an interface. And the autocomplete is going to help us out here. Before I even allow it to start completing by hitting tab, look what it's giving us. Interface, the very first one, is an Objective-C class, and it's a class declaration. And that is what we're doing. We're not going to be talking about categories. We'll probably talk about categories a little bit in the iPhone programming class. Definitely way beyond the scope of this class. And we're not going to talk about class extensions, which are quite awesome, but way outside the scope of this class by a long shot. We must crawl before we stand up and conquer the world. And we must crawl by first knowing how to declare classes. So I'm going to hit tab, and look what it's looking for. It wants to know first, what is the class name? And then there's a colon, and what is the superclass? Jumping back to my whiteboard. So that we could now take advantage of the example that Nina gave us earlier where we can get objects pregnant. So we have
I'm sorry.
a general, it's late now, a generic person.
A person.
And the person has eyes and stuff like that.
Yes.
A weight, a height, etc. And Nina's a bad influence on me. I'm sorry. But now, if we wanted to take person and make a male, so a person has eyes.
There we go.
So yay, a male now has eyes.
Yay.
And if we were to inherit from person a female,
and she has eyes.
She has eyes. But this guy has his
chest hair.
Male organs. And the female has her female organs. And it is only through object coupling that we can produce other objects.
This is perfect.
Yes, it is. But what I'm wanting you guys to get right here is that if I was to go in for real and make a male class, male would have inherited from person. This is the only thing, not Piron, but person. Whoopsie. So that is what you need to understand here. Is just I want you to see where that colon, and it's not like the colon that's in a guy or a female. It's the symbol colon. There's no confusion here. Whoa, I'm pointing to the person's colon. No, we're talking to this colon. All right. That colon is just saying inherits from.
Okay.
So let's jump back over.
All right.
I thought the picture might make it a little bit clearer for you guys to understand. So class name, colon, superclass. So the superclass is the class we're extending. It's the class we're inheriting from.
Okay.
Does that make sense?
Yes.
Okay. So in this case, what is the class name that we want to create?
Oh, oh gosh. What are we calling this?
Can do it. What's the name of your file?
Hello World.
Hello World?
Oh, wait. What file? I'm confused.
Thank you very much, Mandrill. Mandrill's still all over
Message Dispatcher.
The Message Dispatcher.
I'm sorry. I was trying to get more complicated.
You do not want to have a file name and class names different. Bad. It'd be like time to get on an airplane, come visit you with a rotten fish for a face smack. You want to keep your class names the same as the file name. It's a convention. Who do you think my superclass is going to be? Who's going to be the superclass?
Message?
Nope.
No.
You got it, Mandrill. Awesome.
Oh,
Jonathan's right behind him.
Stink.
It's going to be NSObject.
Yay, Mandrill.
NSObject is really, really, really important for us here. It's really important because NSObject contains base functionality for us. Where do you think alloc comes from? The ability to allocate and initialize and retain and release, and ID for Jonathan, who knows what ID is. And it doesn't come from Alec Baldwin. Okay, that's pretty good.
Alec Baldwin.
We need that stuff from NSObject. This here allows our message dispatcher. Check this out. We can now say message dispatcher is an NSObject. Because it is an NSObject. It's an NSObject plus a whole lot more once we get finished defining it and declaring it. Or declaring and defining. All right. So far, I know everybody's following me. Even if you hate me, you're following me. Because I know you won't.
That's right.
So now what I'm going to do, so notice I'm inside these two compiler directives. Now I'm going to do an open curly brace. Which will, once I hit enter, put a closing curly brace for me. And what goes inside these curly braces are our IVARs.
Instance variables.
So we're going to be declaring our instance variables, and you'll find them often referred to as IVARs. So inside here, what variable did we say that we needed in the little picture I drew up over on the board? We needed an NSString pointer.
A pointer.
So let's go ahead and type NSString space pointer, and we're going to just call this message. Terminator. Ooh, Mandro asks a wonderful question. Are these public or private variables? There is no such thing as a private mechanic available in Objective-C. You don't have private keywords. Kind of groovy, huh? It's more like right now I am working, what am I working in? I'm working in a header file, but look at the compiler directives. What am I working in? Give it to me. One word. Starts with an I. And radioactive gets the cookie. I wanted to eat that cookie. I'm so hungry. We're working in the interface right now. What we put in the interface is what we are making available to other people, to other objects that use this object. If I wanted to start doing private stuff, I would not expose it in the interface. But then the funny thing is, the rules that I taught you guys in C about prototyping and where you put your functions become very important. So dealing with this interface, you can just say it's all public stuff. Okay, so now what I want to do is we're going to jump outside of our open and closing curly brace. The curly braces is where we're going to put all of our IVARs. Now I need to prototype my methods. You guys have all seen function prototyping. Remember, I could be like void add numbers int x comma int y and then terminator. Remember that?
Yes.
So this is old-fashioned C prototyping for functions. I also taught you guys that this is completely valid. Remember?
Mm-hmm.
So if I wanted to do an integer pointer for one of them, it would look like that.
Oh.
I mean, I could have done int pointer x, but remember, we don't actually have to have the identifier in there. So I could even, depending on what you like, I could even just put it like that. But now what we're going to do is we're not going to do C-style prototyping. We now need to declare methods that are instance method for message dispatcher. So we're just declaring. So we're exposing these guys through the interface. So here's how we do it. The very first thing that is very important is put a dash in there. Remember when I did the drawing earlier with the cup class?
Yes.
And remember when I said there are instance methods and there are class level methods?
Yes.
And with class methods, you don't have to instantiate a class to use those methods. You just call on the actual class type name.
And those are the plus ones.
And then the method, those are the plus ones. So right now, by using this minus, I'm going in and I'm declaring instance methods that will be available on each of the instances. Hold on to your butt cheeks. This is going to blow you away. That was one of the funniest things I've read tonight. So the very first thing that I want to do is going to be a method that I am going to name exactly the same as the variable that's holding information. This method, I need a way to talk to my variable. I can't not talk to this variable outside of the class. Forget public and private. How do you talk to it? We saw that we only have two things. We can use we can use properties or we can call methods. But there is no dot and direct access to a public field for those of you coming from other languages. We don't have that. So we can't get to this guy. We can't do dot and message. So we're going to use a convention that's been around forever. We're going to create our accessor messages. Surely you guys have all heard of accessor messages. Our getter and our setter. This guy right here, the first one that we're going to create, is going to be our getter. What the getter is responsible for doing is getting what is being stored in message and returning it back to whoever wants message. So notice how we're simulating the direct connectivity. We're simulating the direct connectivity with message by creating a method with the exact same name. So here we go. We know that we want this method to return an NSstring pointer. So NSstring pointer. You don't have to put the space there. I do. It's just me. And now I need to give the method name. The method name needs to match the variable that I want to return the data from. And that is message. Ladies and gentlemen, yay!
Yay!
You guys have just prototyped out your first Objective-C method. And Radioactive's right. He said, for those, let me preface what he said. For those of you that are familiar with properties from other languages, what we've got going on here is we are simply implementing our own get and set methods. Our own, they're called accessor methods. Our own getter and setter. Oh, we're going to be auto-implementing stuff which has been around forever when we start getting into properties and synthesizing them. But that comes up next week. Look, we're already over 5 hours of recorded content.
Yeah.
And we're about to hit, in 1 minute, 6 hours class, as long as Objective-C class ever. All right, so not much longer. It's going to be crazy long altogether. All right, so now we've got our getter, and think of it like this. From externally, if we were to call a message to an instance of this class, and the message that we sent was an invocation of message, message is going to do what? He takes no arguments, but he returns data back. And what we'll do is we'll simply simulate, or not simulate, but when we go to define message, we will actually just return message back. We'll do a little bit of memory management stuff. Well, actually, no, we won't. We won't have to for this. That's just return message. The next one, we'll have to do a little bit of memory management stuff. So this way, it looks like we're actually accessing the variable, but we're not. So if we didn't want anyone to be able to access this guy, it's real simple. Don't put that flipping line in there. We can access this guy over in the implementation file. We'll see him there. He's like a global variable to all of my methods inside the class. They all can see him. Now, we have the ability to get with our getter. Let's go ahead and prototype out our setter. This is why earlier, by the way, when I was programming, I was in, my mindset was in Objective-C. We're going to void, but notice how void is being written out now. And this, again, a very specific naming convention. And Sibai said a great thing. He goes, I thought you hated global variables. This isn't global variables. This is different. It's like global variables, but it's global to the instance of the class. Meaning all the methods in that class can access this guy. But I mean, that's the key thing. It's not global to the whole program. And this is how we set state. Remember earlier when we used the example on the whiteboard with cup and mouse? Those IVARs, those were variables that were global to the class that allowed me to set the color and the size and all that stuff. But it was per each object. Okay, cool. You've got it. All right, so for this guy, the convention we're going to use for a setter goes as follows. Always use set, and then whatever the variable name is, we'll start it off capitalized, so message. Now, message is going to take information in. Very, very funny, Jonathan. I can't keep a straight face and teach with stuff like that coming across BuzzNet. Jeez. All right, back to what we're talking about.
Okay, set.
So remember, what kind of parameter list did we have for message? None. We didn't need one. It's just going to return information. But set message needs a parameter list. It needs a parameter because we're going to be sending it an NSstring to set this guy. So it needs to take in information. So this is how we're going to do our arguments. All right, this is where people start to die on me. Colon. Now we need to specify the type. And then inside of here, so set message, our type is what? An NSstring pointer. Jonathan, I totally agree. This is a good group of people. This is an awesome group. In fact, what the hell? Oh, sorry. What the heck? Our attendees just went up by one.
Wizikin came in the class.
Oh, did he?
Yeah,
hey, Wizikin.
Like, looks like I've missed a crazy night.
Wow, yeah, our number went up, and we're still holding on to everyone else.
Woo woo!
Oh man, Wizikin, you're going to have to go back, and this has been an awesome set of lectures tonight. I think. Okay. Everyone else might say it sucks, but then I'll just kick them all out of class. All right, so moving right along. So now what we're going to do, we've specified a type, and now what I'm going to do is I've got to give an identifier. And the identifier, I can do whatever I want for my identifier here. I'm just going to call this new message and a terminator. The name. So we're all used to functions now. We've done quite a bit of that when working with C over the last couple of weeks and 1 million hours worth of lecture. We've seen that when working with those guys, when we say the method name, like a second ago when I said, add numbers, I could say, what's the method name? It's add numbers. This is interesting here. This method, what's the method name? It's message. This one, what is the method name?
Set message.
It is set message colon.
Oh, colon, okay.
Set message colon is the method name. That is an important one to understand. And next week, we're going to dive into that a whole lot deeper. I was actually going to put that all into tonight, but then all of my method stuff is probably another hour worth of lecture on just that alone. So we won't do that as we're now past midnight. Yeah, baby. Tired my butt, Jonathan. All right. NSG. Awesome. I'm going to have you make one of those later. All right, so moving on. So again, we have simply prototyped out a message that is going to act as our setter for this instanced variable. And it takes in one argument. So the parameter is simply NSString pointer with an identifier, new message. So now we have another one that we got to do. And remember, we need the ability to print out. So for this one, we're going to say it's going to be void, because all we want it to do is just print out to the console whatever is being stored in our message IVAR. So this guy is simply going to be dispatch message. Now, does dispatch message, does it need to take anything in?
Oh, wait. No, it puts out.
It puts out.
Oh my God.
Awesome job, Nina. That's right. Dispatch message puts out. It does. So I can go terminate, because it's just going to simply write out to the console whatever we're storing in here. And to be more appropriate, we're going to print out whatever the NSString pointer message is pointing to that NSString. Will get written out. That's it, ladies and gentlemen. This is our header file. You have written your first implementation for an Objective-C object-oriented program. But this is, or not implementation, interface. You guys are getting slow at correcting me too. Now, like Radioactive says, warning, coding time may vary. Some of you guys that are finger pecking or chicken pecking the things out, you may still be writing. No, surely everybody is with me by now. So let's see. Stealth Coder says, so you have a variable pointer message and a method called message. Yes, that is correct, sir. So that externally, we can simply call on message, and it looks like we're talking to the message variable, if that makes sense. Okay, good. All right, so I'm proud of you guys. I know every one of you are following along. So now let's do the next thing. And what is that? I said over on the whiteboard that when defining a class, we must break a class into two parts that are required. Oh. The first part is the interface. And the second part is the implementation.
Implementation.
That's right. We need to implement everything that we have declared. So let's do that. Everybody, with me. Right-click on your OOP Hello World folder. And let's go ahead and do a new file.
New.
Empty, ladies and gentlemen. We want it to be empty. Hit next. What do you think the name is going to be based off lecture I've already provided? All right, Mandrill is awesome. You get the cookie that time. Almost out of cookies and I'm starving. So it is, like Mandrill just said, it's going to be the same thing as our class name, message dispatcher, but then .m indicates that this is an Objective-C source implementation file.
Is this the part where the methods come in?
So now we're going to define them.
Oh, okay.
So this is where we're going to start coding. So message dispatcher.m.
Create.
And hit create. Empty file.
Wow.
Yeah, baby. So we're getting there. The very, very first thing we need to do is what?
Import our header.
You got it. We need to import. Ooh, Nina's getting ready to copy the stuff that we had over on the other one. That is wrong.
Oh, no.
Watch this. What we need to do is import. And now we're going to use the quotes.
Oh.
We're going to say import message dispatcher .h.
Oh.
By importing message dispatcher.h, everything that this guy imported, foundation age and standard IO, is imported automatically into here. That's what I meant earlier by it keeps things clean.
Look at that.
And C-By is absolutely right. Import equals include on steroids.
Woo woo.
So now, And yes, Jonathan, this is 25 lines of comments to inform users that we're going to print hello world. But this, I really love this example because I thought it would kind of help show you guys the big picture before we get lost in the forest. So inside of here, what we need to do now, if you guys recall, over in our interface, we had to tell the compiler that we had an interface section defining our class. Now we have to tell the compiler we have a, anyone? Implementation, I'll help you out here, an implementation section. That's what it is. It's an implementation section. So what I'm going to do, and what you guys are going to do, is we're going to type implementation. Look at that. Just like before, we're starting to get a little help now. Implementation, if we're going to be doing an Objective-C class implementation, well, we are. So we'll hit tab, tab again. Now we've got to give it our class name. What's our class name, ladies and gentlemen? Message Dispatcher. Look at the big icon that says C for class, and it's all like being helpful.
Look at that.
So I'll type that in. And look at this. Since we used the code snippet for us, it filled that in. It put the @in for us, and it has our method. So like just hit tab. It's like the best reminder in the world. It's basically saying, look, knucklehead, now between these two compiler directives, you need to define your methods. Mandrill, no. He is asking, no superclass here? No. We have already done the inheriting part in the interface.
Interface.
So now it just gets easier and easier from here. Or does it? All right, so now it's time to simply implement. How many methods do we need to implement? Come on, guys. How many methods? How many methods? How many methods? Let me see. Come on. Somebody get it. Somebody get it. All right, so Mandrill says 3.
Is it 1?
Radioactive, who I know knows something about Objective-C, is smoking crack and decided to give us 1.
That's funny. He just
So I see another 3. A 2. Radioactive is now leaned back against the wall because he's happy about what he's doing. Nelson said 0.5. We need to, this is very important. We need to implement 4 methods.
4. Everybody was wrong.
I know.
Look at that.
This one's tricky. Let's do it. The very first method that we need to implement, let's just follow straight down the list of what we had over on the other. As a matter of fact, often what I'll do, for the sake of speeding up time, yeah, you guys want me to do it for the sake of speeding up time. I'm going to click on the header file.
Oh, how'd you do that?
I clicked right here with the left mouse button.
Magic.
I am now going to highlight these guys by left click and dragging.
Got it. Oh.
This is how I always did it in the past anyways. I mean, anytime I can save from having to retype stuff, I'm happy. Now I'm going to hit Command C to, wait for it, copy to the clipboard.
Woo!
Now I'm going to jump back over here to my implementation file. Click on header and hit Command V.
To paste it.
What'd you say about toupees?
I said.
Oh, to paste it.
Paste it.
My bad. All right, so we've saved a little bit of time. Rock and roll. All right. Now we need to clean this up a little bit. We're doing actual methods now. So, I'm not done, Jonathan. So we're going to come in here, and I'm going to give the blocks to these guys.
Block.
So everybody go ahead and block these guys in. Take out the terminator at the end and block them in.
Okay.
Nope, we're not going to do a init. We'll be talking about doing custom initialization next week. Hey, SAG 10,000,000. Yeah, just joined in for the first time. He's been so quiet tonight. He, she, I'm not actually sure who he, her is. I say we do initializers tonight. Nelson, are you starting to wake up now?
He's on his second wind.
Yeah, we just push it all night, man. Okay, so I'm going to go ahead and put,
Dalai Lama.
I'm going to put one more in here. I'm going to do a dash. What does a dash mean again? Quick.
Oh, that's the Oh my
Oh,
gosh.
you guys got it. This means we're going to be doing an instance method.
Oh yeah.
All right, very good. So we're actually going to be overwriting a method here. And that gets us into some of our discussion from next week. But one of the things that are available to us on NSObject, meaning all of our objects have access to it, is the ability to dealloc or dealloc. I always just say dealloc, but deallocate. So let's go ahead and put this guy in. I'm going to put in a void. He doesn't return anything. And then I'm going to say DE, and look at that. DE, oh wait, DEALL. There we go. Dealloc. Man,
Alec.
I'm not tired, am I? What the heck? So let's go ahead and put that guy in like such. And what is going to end up happening with dealloc is we're going to need to do a little bit of memory cleanup very soon. And so I want you guys to see what's going on here when we do it. But in the very first thing, when we're going to dealloc, is we've got to make sure that we call, anybody have a guess? I know you guys can get it. It's really kind of easy.
Oh, wait.
We have a class, it's called Super. And we're going to call his dealloc.
Yeah. Super dealloc.
Yep. It might sound goofy. This is very, very important. The moment we override dealloc, if we don't call super dealloc, we're going to cause all sorts of trouble because NSObject has some of its own cleanup stuff that it does. So this is how when we inherit from a method, we can override that method with some of our own functionality and then tell that method to run. So super just means, hey, we inherited from NSObject, so call NSObject's dealloc.
Okay.
And if that is making you right now go blah, 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 and freak out and like run around the room or something, don't worry about it. Okay? It's all good. No stress, because we're going to be talking about polymorphism and overriding methods and all that stuff in more detail next week. So I'm setting up the base here. So now, the only thing that resides in this implementation file is just the definitions of our methods. So the very first one, so now let's actually start putting some stuff in here. Message. I've already told you guys what needs to go in here. What needs to go in the message getter? Not cookies. No kind of special cream.
Oh, wait. Hold on.
What does it do? Message serves as our, yeah, that's right. Oh, getter. It's our getter. Thank you. Very good. We're going to return message.
It's a getter. Oh, okay.
And just a reminder that for those of you that do know Objective-C, this class is designed for the complete beginners. As Mandrill's about to have a meltdown. Hang in there, Mandrill. So, you can see that this method is very, very, very easy.
Return message.
Let's now jump down to dispatch message. And the reason I want to jump down to dispatch message is because we've got a couple new things that I want to talk about in set message. So in dispatch message, the only thing we need to do, everybody should know how to do this. We're just going to do a printf or an NSLog if you want to. I just don't like all the extra stuff. So I'm going to say printf, and I'm just going to use a string formatter. And then I'm going to tell it, you guys saw earlier, I'm going to send a message to message. And the message that I'm going to send, now remember, message is it's an NSstring.
Shoot.
And NSstring has a whole bunch of functionality that's built into it. So I'm going to call upon, you guys saw this a minute ago, C string using encoding, and we're going to use NSUTF-8. So let's go ahead and put that in real quick.
Oh, wait. Come on.
So again, very simple stuff. No, seriously, I hope that I'm not frustrating anyone in this class that already knows Objective-C, because this is it's an introduction to Objective-C. And Nina's typing it out.
Ah.
So use the use autocomplete for you. It is your buddy.
Come on. There.
Yep, those are some long words. You're absolutely right, Sibai. You're going to find Objective-C to be an extremely verbose language. Extremely verbose. All right. This means at this point we have the ability to get. To get whatever's been put into message. We have the ability to dispatch a message. Now what I need to do is set the message. So what I'm going to do for setting the message is I'm going to say new message, because remember that is my parameter coming in, and I'm going to retain it. Remember right here, when we call set message and we send an argument into it, that argument is coming in. That argument's an address. So we're holding a reference to an object. So we've got an object. Let's just say we've got an object coming in. I want to retain it. After I've retained it, I'm going to take my current message that I have right here, and I'm going to dump it. I'm going to get rid of it. So what I'm going to do is I'm going to do message, and I'm going to call release. And now I'm going to take message, and I'm going to let it be assigned to whatever new message was. So here's our first little bit of simple memory management. How did you end up getting moved over there? Oh, I guess that's right. Yeah, just looks funny. Okay. Why am I doing this? I'm putting this in place because right now it's all a very set, straightforward system that we're going to set up in main, and we wouldn't need to do anything complicated like this. But I'm doing this on purpose because we are inside a class called Message Dispatcher, and we don't know what other methods, what other classes may be working with an NSstring message. Okay, so we could have another class that's working with an NSstring that calls a retain on it. So somebody else that increments its retain count. We just don't know. So what's happening right here is we're basically saying that we are taking ownership of this guy. So we're taking ownership, and we are relinquishing ownership of the message, the NSstring message that we have. Remember the IVAR that we put together back over in our implementation file. We're releasing that. Well, anyone with a keen eye is going to say, well, wait a minute, Jason. I don't see anywhere in here where you have initialized your message variable. I'm not talking about the message method. I'm talking about the message variable, this guy here. We didn't. Objective-C, the compiler will initialize all of our objects to nil. N-I-L, lowercase.
Nil.
And the most awesome thing in the world is that you can call methods on nil, and it's a no-op for the CPU. And for those of you that don't program, you don't understand the absolute glory of that. You don't have to test to see if the object is null. And people like Radioactive appreciates it. So it's really, really cool to be able to say that I'm going to, so let's jump back to the implementation file. It's very, very cool to say, because the very first time we send a message into here, we take ownership of it and we call release on our message, but there's nothing in there, but it was initialized to nil. So this is a no op the first time through. So nothing happens, no operation. And then in this next line, we now assign new message over to message. So message is now pointing at the NS string for new message. And what did Nelson? LOL, Jason said method plus massage, meth sausage. Okay, it's kind of scary actually. And McSausage sounds really good. Shut up, Jonathan.
Oh.
No, I'm hungry. Okay, so there's only, do we see, and Radioactive, you're welcome to jump in on this one quickly. And so are you, Mr. Sag, 1 zillion. Right now, there's only one last thing that we need to do in here that deals with memory. And what is that? Does anyone have a guess? If a couple of the people that know don't say. People will wonder. Anybody? Anyone? Bueller? Bueller. All right. We've basically said that we're retaining new message. But new message, this object that we're retaining, here it's the same object. So since we are holding this guy, Sag almost got it. He's right, but we can't use new message. I need to come down here to dealloc. When this object gets deallocated, I need to, since I was taking ownership by retaining an object, I need a final release because I retain the new guy, I release the old guy, but this guy right here, he's being retained. And we're not releasing him if we don't call setMessage again. So down here, this message is now pointing to that guy that's been retained. So what I'm going to do is simply come down here and I'm going to say we need to tell message that it needs to be released. Or release. Tired. So that everything is going to balance out. And absolutely, Sag, you got it. Jason needs a release. You guys are horrible. I am getting my release. I love to teach. I love hanging out with you guys. We still are, Nelson, we're still +1 with Wizzykin coming in. We still have all of the people that have been here for so many hours now, and it is now 12:30 in the morning. I am beyond blown away. Yeah, I'm shocked. Okay. So we've created a class. We've done the two things that I said must be done when creating a class. The first thing is you must have an interface. The second thing is you must have, I can't look at BuzzNet no more. The second thing is you must have an implementation. So we now have an interface and an implementation, and we saw that we divided the two things up. We could put it in a single file. We will not do that. I just looked back over and saw Sebai talk about zombies.
Class of coding zombies.
I know, but the funny thing is we're going to be dealing with zombies a little bit later on.
Oh, yeah.
Oh, which is very cool when we start talking about the profiler and all. But all right, let's get back to this. But yeah, we will be talking about zombies. So let's take a look at what Mandrill just said. He says, oh, because message was declared as a pointer, that's right. When you call setMessage, that's when you initialize it. Absolutely. Very good, sir. And before setMessage ever gets called by us, the compiler, since this is Objective-C, initialized it for us to nil so that we can safely call messages on it without worrying about death and destruction, meaning crashing. Okay, so now we have a class. Let's make sure that we hit Command-S, save your stuff. Let's go back to main. Oh, geez, main's empty. We need to put something in main, don't we? What do we need in main?
Do we get our little dudes that we made? I'm just kidding.
Shouldn't message dispatcher.m actually have a .h extension? It does. Unless I spelled it wrong, which would
What
be
happened?
right here.
Yeah.
Message dispatcher.h. And then over here in the .m file, we're importing the header file into our implementation. Did I accidentally miss something? Hi, Ashley, welcome back. And yes, the class is still going. All right, so with those two, unless I missed something, let's go ahead and jump up here to main. All right, blank screen, what do we need first? Anyone? Bueller? All right, Dementis says let's start out with an import. Import. What do we want to import?
Oh my goodness.
Tell me what to import. Radioactive, what do I import? A header. What header file? Somebody type in BuzzNet. Standard. What?
The foundation thing?
All right, Mandro says import message dispatcher.header. All right, so message
So smart.
.header file. Okay, got him in. What else do we need? Have I missed MESSAGE?
So then we need to do the message dispatcher.m?
So no, we just need to import that in.
Oh, okay.
Now we need a function.
Err.
We need a main function. And Jonathan's right. Standard IO was already imported in the header file for message dispatcher. You gotta love import and the way it works. So we already have access to all of that. So now what I'm going to do is we need to say int main, because even in Objective-C, you must have a main function to start with. Notice how I'm not in an object. I'm doing regular function, regular procedural programming. And I do agree with what Jonathan said. Let's go ahead and put return 0 in. Just good practice. Okay. Now we're done. All right, the next thing. I saw auto release pool. Do we need an auto release pool in here at the moment? Are you sure? Let's get to auto release in just a moment. Let's start this out with making a message dispatcher. So we have a class. I need to instantiate that class now. So let's do that. I need to make a variable first. And the variable will be type message dispatcher, and it's a pointer to and I give it an identifier. It's going to be a pointer to a dispatcher. So far, so good. Now this next section is going to get a little wonky. I've drawn this out. We're going to talk more about this next week, but what I'm going to do is, well, let's just go ahead and first we need to initialize, or we need to allocate the space for this guy. So let's just do it here. Let's just all together. So we're going to say message pointer for dispatcher is equal to, so I have to start out by a call to the type itself. So message dispatcher space alloc. So we're going to allocate the memory amount that's required and set it up for to hold in the heap for a message dispatcher. And this guy will give us an address back. Now what I need to do is initialize it. And generally, I just initialize all at the same time. So you can do nested method calls. Ooh, Mandro just pointed out the most beautiful thing in the world. Let's go ahead and do what he just said. He said, let's do a method to dispatcher. And let's call init to initialize it. I wonder, just curious real quick, if the analyzer is smart enough to catch this. Potential leak of an object. So yeah, it knows something's going on. Are you cool enough to... Come on. Oh, you're not going to give me what I was hoping to see. No, yes, wait. There we go. All right. Now, apologies. I'm getting just a little bit. I just want to show you this right now. We're going to be talking about retain counts or reference counting. And what's going on right here is we actually can run into a situation where we can end up screwing ourselves up and causing a memory leak. Let me be careful. I'll come back to this later. This leads into another discussion, and thinking about it right now, it's not a wise idea. It's late. I apologize. So let me just jump out of that and back over to here. I was about to go off on another tangent. Don't let me do that one yet. So I'm going to go ahead and wrap all of this up into one, because this is how you're always going to see it. Instead of saying dispatcher equals and then call dispatch and initialize, I'm just going to come into here and do a nested method call. And so with the pointer that we get back from the message dispatcher alloc, I'm then going to call init on it. Okay? Yeah, I'm trying to be real good about my tangents, especially if they can lead to rabbit holes that get nasty. So let's see what we have over here. What kind of warning do we have? We have an unused, empty love bucket. All right, so what we need to do now is set it. So I'm going to come in here, and I'm going to use my dispatcher now. I'm just going to send it a message. Hi, dispatcher. I want to set message. Set message is expecting one argument, and it's expecting an NS string. So I'm going to do an NS string constant, and I'm going to show you guys an interesting problem in a minute. So I'm going to say, hello, OOP world.
Hello. Whoops. Oh, wait. Bracket. Terminator.
Okay, so at this point, all I've done is a method.
Yay.
Call, but let's change our terminology here. All I've done is a message. I sent a message. My receiver was the dispatcher, and I told the dispatcher that I wanted it to invoke its set message, and I'm sending information to it. So that's it. But now we need to make sure that it actually worked. So what I'm going to do here is I'm going to say, let us go ahead and dispatch a message. So dispatcher, dispatch a message. And remember, dispatch a message doesn't have any arguments that it is expecting to be passed to it. So I've now sent some groovy stuff out. So I'm done with it. So now I'm going to say dispatcher, sending it another message. I want to release you from duty.
Ooh.
I run it. It's griping about the auto release pool, which we'll put in place in just a second. But hello world, hello OOP world. And Jonathan fails.
Aww. Mine worked, yay.
And I didn't get that warning. and mine made popcorn. Nina didn't get the warning either. Well, actually, she is getting it echoed out down in the bottom in the debugger.
Debug.
So we're going to go ahead and we're going to set the auto release up. You will always find an auto release in main. And an auto release, all an auto release is a delayed, it is a delayed release method call on all objects that have been added to the pool. And the funny thing is, all the objects that have been added into the pool, it's only one release call on everyone. So if some other method in some other object took ownership by calling retain and did not properly release, you will still have a memory leak. Because that pool doesn't guarantee that the object's going away. The only way the object gets deallocated is when its reference count hits 0. When that retain counts at 0, it automatically, well, not at that very second. My understanding is it might be a little delayed, but it gets deallocated. And the memory from the heap is then recovered as available memory that can then be used. Now, this guy is awesome because using the auto release pool, we can start creating things that are available to us inside of framework, like NSString, for example. All of these other objects, most of them, will automatically register themselves to an auto release pool. So you'll find in a lot of examples in main, if someone's working with the creation of NSStrings and all, you won't see them releasing them. And you may get confused why with me, you saw me back over here in our message dispatcher actually releasing an NSString. It's like, well, why are you releasing an NSString there? But if you were to come back over here into main and inside of an auto release pool, you don't have to because it's going to be automatic. So what I'm going to do is I'm going to come on up here, and I'm going to say, compiler, I need you to set up an auto release pool, and it's going to set up a whole block, and I'm just going to cut this guy out, paste him down here, and this is just me. Move this guy down here and indent.
Wait, oh my goodness, what is it doing?
And Command S, build and run, and look how clean, sexy, amazing that is. My output's so much better. The compiler's happy. Computer's humming along. All is good.
Yay!
So now you might be wondering, well, what if I didn't want my message dispatcher? By the way, don't put the message dispatch or the dispatcher release, don't put that outside of this block. Because look at him. Where's he being defined at? He's being defined inside of the block. So because of scope, we can't do that. But what if I didn't want to do this? What if I wanted the dispatcher to be, added into the auto release pool? All I got to do is a message call to dispatcher and tell it auto release. Terminate. Now, I no longer have to worry about releasing him myself. Because once we get done with all of the execution that takes place inside of our auto release pool, then we're going to end up, if you want to get psycho, go for it, man. Mm-hmm. Yes, you could do that, but that's pretty nested now. You're 3 down. Code's getting kind of hard to read, Jonathan. No cookie for you. I'm going to set this one to the side, and I'm going to eat it later, like in 5 minutes from now. So that's like the father of ARC. Yep, it sure is. It's like reading the Japanese language. Yep, it sure is. Now, ARC is the automatic reference counting. We're going to be dealing with automatic reference counting probably won't talk much about it next week, to be dead honest with you. And the reason is, when you say that you're going to use automatic reference counting, you saw how I'm using these retains and releases? The compiler takes care of putting all that in for you. So we're not going to, it makes life easier. I think it's very important from a beginner point of view, or even somebody new to learning Objective-C, I think it's very important that you understand how reference counting works. And that is why I wanted to cover this. I could have taken the cheap way out and said we're going to use the automatic reference counting, but that would have been lame. All right, so that's it. We've now made a program that I can build and run. And it is an object-oriented program. We created a header file and an implementation file. In the header file, we imported the things that we needed to import, and then we defined the implementation section. Then in the, I guess I could show this. Just because I've mentioned it a couple of times tonight, let's have some fun. If I come back over here to, and I know somebody just rolled their eyes. They're like, are they going to ever end this class? Jeez. No, we're already there. So what I want to do is I want to add one more method over here, but look at this. With a plus. What does that mean again? What kind of it? Jonathan, hang up. What kind of method is this? It's a class method. Good job. All right, Jonathan, I take it back. All right, so what we want to do is we're going to say void, and then we're going to say that it's just like, I don't know, say hi. The most awesome, most awesome in the world. So let's go ahead and copy that. Now let's come back over here to our message dispatcher. And then in here, it doesn't matter where I put it. I'll just come down to the bottom. Let's go ahead and paste it in. And then I'm going to say printf and say boogie stuff. It's been a long day, ladies and gentlemen. A long day. All right. Now, how do I use this? Yes, the name is misleading. And this is bad design. It does not say hi. It says boogie stuff. Watch this. I'm going to go back to main. And inside my auto release pool, what I want to do is I'm just going to quickly jump down here and comment these guys out. So I do not have an instance of the message dispatcher. I'm going to talk directly to it. Message dispatcher, say hi. So we're talking to, now I'm going to jump back to super elementary terms. We're talking to our template. We're talking to our blueprint directly without even having made something from it. So let's go ahead and save and run. Boogie stuff. So now you've seen examples of both of the, an instance method and a class method.
Woo!
And you can use both. You can do really cool things, like you could set up your own creation of an object on a class. So I could have a class method on message dispatcher that creates an instance of himself and then returns that back to the caller. So the caller could still be saying, hey, I need to get a message dispatcher, an instance of it. But to get it, instead of doing the alloc and init, I'm going to call message dispatcher create dispatcher. And then create dispatcher simply could come in as a class method and create an instance of himself. But the cool thing is he could then start tracking, how many dispatchers have I made? How many things are in each of the dispatchers? So then later I could call on another class method for message dispatcher that could be show dispatcher information. And then what that class could do, or that class method, is then turn around and say, All right, so these are all of the different dispatchers that have been created and handed out. And let's see, I have a question now. Why, if you uncomment all your code, it causes a runtime error? But if you comment everything but the class, it worky fine. I don't know what you're talking about. Works fine for me.
You broke it.
Ah, Jonathan done screwed it up.
You broke it.
He done screwed it up. He failed and doesn't get his cookie. Want a cookie, Nina?
Yes.
Here you go, man. There's
Woo,
your cookie.
thank you.
You're very welcome. Yes, it's a tasty cookie, too.
It's mighty nice.
Yeah, it is a mighty nice cookie. All right.
What in the... Because he's doing all
He's
that crazy stuff.
See,
All that nesty McNesterson stuff.
Yeah, that's ugly.
Wow.
I'm going to nest within a nest and nest some more nestings, and then I'm going to call the nesting fairy and tell her I want some nesting dust. I don't even know what you have going on right now.
Oh,
Sure it's not formatted that way. You're like, right, I'm going to write this whole thing out on one line.
oh my.
All right. Send code. Nelson, you want to give him a send code button in BuzzNet? Just call it something like Jonathan Fail. So later when we go back to the database and we'll know exactly what that was. Oh, Nelson was nice. Just for Jonathan. All right, Jonathan, post your code in there. Better be easy code for me to read.
What'd he do?
Let's see what he's got cooking here. I like initialize, dispatcher, auto release. Why are you auto releasing and releasing? That's going to blow up, my friend. Memory management. When you do the release, all right. Let me get everybody. Let's all make fun of Jonathan. I'm sorry. Let's all show Jonathan we love him. So what's happening here is Jonathan had the dispatcher going into auto release, but he also had dispatcher release. Let's talk about what happens. The auto release method simply registers this dispatcher in this auto release pool. What the dispatcher does here, when we allocate, and we're going to get into this in detail next time, but what this does here is it's going to return us an object with a retain count of 1. Remember, when our retain count hits 0, it's deallocated. So currently our retain count is 1. This doesn't adjust the retain count at all. It registers ourselves to the pool. This line right here says let's take our retain count and decrement it by 1. So what did I say a second ago it was? 1. What's 1 minus 1? 0. What did I say happens when we hit 0? It gets deallocated. Now we hit here. So it's now time for the auto release pool to send out a release message, the same thing you did here, but the auto release pool does it for him, or does it automatically for you. So it's now going to send out a release message to all objects that have been placed in it, which means dispatcher. Dispatcher is told to release, but it's already been deallocated. It no longer exists. Add memory. You're going to get an exception. Your program go boom, chicka, exploding. You're welcome, sir. Did you take that out and everything run fine? It did not. Yes, it did. Okay, good. Sounded like some funky music is what he said.
Yeah, I see.
All right, so that is all that we're going to cover tonight. And by goodness, for any of you guys that are friends of mine over on Facebook. I'm going to make a comment about this being an epic class, and I sure hope you guys follow up with, yes, it was epic. Because we're now looking at a, 7-hour class with over 6 hours of recorded lecture time. This is without a doubt a long mammy jammy. But we covered a lot of stuff. No laughing at me when I tell you we only made it to page 12 of 16 pages, but I do want to say this. A lot of the stuff that is in the remaining pages, a whole lot, has already been, I've already covered it. I just rearranged the order as I was explaining. Okay? So, next week, we've got more discussion that we will be doing on object-oriented programming. It'll be part 2. We'll start getting into polymorphism. And we're going to have a lot of fun with that one. And we'll take a closer look at memory. We're going to recap on all of this. And I will get this class posted. And what I want for you guys to do is, I don't know, Nelson, we'll talk about homework. We'll come up with homework. Because I was just more interested in making it through all of this lecture so that you guys have got a strong intro into Objective-C. Do we still have hunting? Mandrill, you still with us? Checking to see if Mandrill's still out there. Nina's about to die. Awesome, Mandrill stayed. How was that, sir? Was that a decent crash course intro to Objective-C?
He said, yeah.
Hells yeah. Good. Yeah. I mean, there are so many things that we still need to cover, and so many quirks. But what you guys have seen tonight is really the basic fundamentals of putting together an object-oriented program in the Objective-C language. Yep, basics. Oh, Brian, it's got to... When we get into iPhone programming, because I know you're going to be there, oh my gosh, some of the stuff's going to get confusing. Good. Glad that you understood a lot of it. All right, guys. Thank you all very much for hanging out with me for so long tonight. You guys are so awesome. I do appreciate it. You guys all go have a wonderful night, and look for homework to be posted tomorrow because it's like 1 o'clock in the morning my time now. And I'll get this encoding, which will probably take all night. No, it'll probably take a good hour or so to encode. And then I'll get it up for you guys to go back over and review. And yes, Jen, I'm going for dinner. So
popcorn,
thank
probably.
you. Probably so. Bye, everyone. You guys are fantastic. Thanks again. Bye, guys.
Bye.